from Morutu? Yes, you Morutu. One person. You and I. No, I'm not going to do Morutu. Yes. Then Perali. IIT. I. Then Slit. Then you're also from Slit. So others, you're from IIT. Slit. Slit. Slit the throat. Yeah. Good. Right, cool. So it's very nice to be a part of this thing. Thank you for that warm welcome. What's your name? Yeah. Huh? Otara. Utara. Like embark name. Huh? Yes. Cool. So thank you for that warm welcome. So let's start this thing. So I thought of is this thing? Okay. Right. So, who is Nushar? Let's start from that. Yeah, you should know who I am. Some people are from this stuff, and this bugger is coming and telling about AI. There's this bugger, all this stuff, and all. There's a problem, right? So, I will a little bit of an introduction. So, I'm a researcher, a very young researcher, actually. I'm also in 20s still, not 30. So, it's like an idea for you guys. Everyone is like 21, 20, 22 or something like that, right? So I'm like 20, 29. So closer to 30, but still young and running. So I'm a researcher in applied AI. So I research in how to apply AI in different fields, in different domains, and also coming up with cost-effective AI solutions in at SLIT. In electrical and electronics engineering, we are running convolutional neural networks, vision-based neural networks on boards which has 512 MB RAM. Smaller boards. Today we are not taking these big Raspberry Pi boards. We are not taking Raspberry Pi 5. If I ask you like, yeah, well, where are you going to run your neural network? You say Jetson Nano, that Nano, this Nano, Lilipad, that Panda, this Panda, that Panda. We are taking off that whole era aside and we are starting to run programs in neural networks in Arduino boards, ESP32s, and in Raspberry Pi Zero, like 512 MB, very small RAM. So I'm going to show you today about those kind of stuff, how do we do it. So this is my research field. So I did my PhD in developing an AI tool to identify atypical children, abnormal children. So by looking at their behaviors, how they walk, how they move their body, by looking at this thing, early identifying if the child is having some sort of a disability and alerting that okay, there are some treatments today. And also to check how the interventions that has been taken to cure this disability is effective or not. So that was my PhD about. So currently I'm working as a lecturer to the Department of Electrical and Electronic Engineering at SLIIT, and also as Utara or Otara said, I'm currently an external researcher for the University of Oxford in the United Kingdom. And also I'm currently working as a external research engineer at the University of Applied Science and Arts in Southern Switzerland. Also, I'm a senior consultant in the Defense Ministry. CDRD, I don't know whether you have heard about this, Center of Defense Research and Development. So I'm working as a senior consultant there. Also, I'm a consultant in Maskrida on coming up with these cost-effective AI solutions for. So this is my background. This is what I do. This is what my career is. So whatever I gain from other countries and working with the external researchers, looking at how the other developing countries are working, my responsibility is to give that share that knowledge with you guys. Yes, and make sure that the young people in this country are coming up with AI solutions with the effect. Not just okay, looking cool, I know neural networks. Your mother is going and boasting saying that my son is creating AI, but you don't know what the hell is AI also. You are putting from ChatGPT and ChatGPT is generating the AI. Anyways, so we'll see. We'll try to cover up as much as possible. It's not easy. This is like years of work. We are trying to give it to you guys. So it's a IIT. So we have a lectures and we are teaching it. But I only have like how many hours? 4 hours. 4 hours of seeing this face. Yeah, not gonna work. Yeah, even the girls are chewing like so 4 hours. I understand it's a very long time, but I'll try to make it interesting. Well, that's me. So today what we are going to do is we are going to talk about AI and advanced architecture in AI, right? So in order to figure out this whole, what are these advanced architectures and everything, first of all, the question should come to your head. What is AI? What is it? Dude, we are here to learn that thing. Yes. What is AI stands for, at least? Yes? Okay, three people know that AI is. AI is what? Artificial intelligence. So let's take a breakdown that word. What do you mean by artificial? What is the meaning of artificial? What do you mean by artificial? Yes, something synthetic, something that you're creating. That is pretty obvious, right? So what are we trying to create? Intelligence. Yes, this is the part that we are trying to create. So artificial part, anyway, something creating. So we are the ones who are going to create what? Intelligence. So we have to take a step back and figure out what is intelligence. Yes. Next question is that, right? So in order to create something, now you guys are engineers, right? Electrical and electronics engineers, software engineers, whatever the engineer you are, you guys are engineers. You guys are some bosses, right? You call it boss, the worker who's going to create something. So actually, it's the posh version of the boss is engineering. Yeah. So you're going to fix something or make something, build something, a carpenter kind of a person. But you have to have a sense of what you are trying to make. So you are trying to make intelligence. So we'll take a step back and try to understand what is intelligence. So I will show you this small clip. You guys have watched this movie? You guys haven't watched this movie? Yes, you guys have. You have watched. Who is this guy? Inspector? Clouseau.
Who was? Your bowls. I would like to take a closer look at your big brass bowls. Okay. Thank you. Han Dynasty. Very well, beautiful.
Oh, I see you have an eye for antiques, Inspector. Some here are real and some are copies. I'm sure you can tell which are which.
2nd century. Very well.
Yeah.
One should always handle an antique vase from the inside. Otherwise, the oil from the ends can damage the patina. Oh, pure alabaster. Lovely. Oh. That's odd. They did it. They went like this, and then. Hmm.
This is weird.
Why did you take out a life insurance policy on Lyon?
The insurance company won't pay unless the murderer is caught. And if it turns out to be me, they won't pay at all. Do you understand?
But you stood to gain from Gluon's death, didn't you?
Gain? What would I gain?
You want to share the restaurants?
Oh, the restaurants were a disaster. Gluon was siphoning money out faster than it came in. My only consolation was he'd lose the money gambling in my casino. But after a while, his losses became so ridiculous. He promised me his ring as collateral.
Then when it was with Gluon, the night before he was killed, didn't you? No. You didn't threaten to break his legs and then crush him into powder? No. Perhaps I saw that on TV. Oh. But I can certainly think of a better place for these. It's my personalized cell phone tone ring. Hello? Yes, it's Inspector. Yes, I could meet you. In the restaurant? Yes, of course, right away. Gentlemen, something has come up. Please excuse me. Is he all right?
Yes,
Is this vase of great value?
it is a worthless imitation.
Good.
But that desk was priceless.
Right. You saw something. What sort of a person is this guy? Is he intelligent? What do you think? Some people are saying yes, some people are saying no. Is this guy intelligent? What do you think? The way he acted, is it an intelligent way? Yes? No. Why do you say no? Because the way he acted, the action showed that that guy is stupid as hell. He wanted to take the last letter, he did the same thing again, and the two arms got stuck. So the action defined your intelligence, right? So then, how would you face that scenario? You would look at it, analyze it, then act, correct? So this is the thinking process that is called intelligence, yes? That is what we are telling, that intelligence. Yeah? So it's not the actions what we do. It's not the actions. It's not the actions that we do, right? It's the way of doing. Yes? Yes? Yes, young lady. Yeah, come, you can come and see. So, this is intelligence, right? This is what you, when you see something, someone in this room poking his finger inside and eating the boogers. Then lady's face, yeah, disgusting. He called it. This person doesn't know what to do. So intelligence, actions show significance. But what does, how do you lead to that action? How do you make it proper? Is intelligence, yeah? Yeah. So, anyways, when you take the great, sorry. So if you take the definition, it's problem solving, reason, logics. So now we understand this thing a little bit. What intelligence is, to differentiate what is not intelligent, what is intelligent. Yes? Yes? You know it. Now we'll try to bring a small flow chart to this. Try to understand this. Now let's go and simply understand intelligence. So even Inspector Clouseau sense something, right? You guys sense something, you see something, you see this, you see the race, you see it. Then what happens? You're seeing it, you're seeing it, you're seeing it, you're sensing it. There's something. Let's say there's a nice, good looking girl. You see it. You don't do the action, right? You go forward and do the action. I love you, I want to marry you. Then what should we do first? We saw. But we have to process. You're thinking, okay, that's a good looking girl. That's a good looking guy. Yes? So now we are processing how to get this girl or the guy. Either way, I don't mind. Yes? So processing part. Then only you have to go for an action. Yes? Then only you are going into the action. So, sensing is what? Is it intelligent? You in the whole intelligence process, you have three parts. Sensing, sit. What do you think? Young lady who came late. This sensing gives something. No, you're saying no. And my other question is why? Why are you saying no? No, guys, when I do these lectures in Oxford and Switzerland, and what I see the difference in Sri Lanka is that you are not asking questions. I have to ask questions. But if you go to Oxford and you just show this thing, they are asking tons of questions. Why this? Why that? Why are you like this? Why are you dressing like that? So many personal questions are also asking. Then okay. So you should ask questions. If you're not asking questions yourself, you're not going to figure this thing out. You ask questions only, you seek for the answer, then you get the knowledge. So my second question is, why are you saying that sensing is not intelligent?
Because everyone is feeling senses, but the it's a part is how processing is done. Even the expectation is feeling senses, part is processing is the part is like.
Very good. Very good. It's like sensing is just what? Just information, yes? Even Inspector Clouseau, he saw the waste. He didn't think about it. He did the action. So, which means the action, directly doing the action is not intelligent at all. So, action is also not intelligent. It's just your motions. The action is not intelligent. But the processing part, that's what intelligence is. So, all these people are defined as intelligent. The intelligence is defined through the brain, actually. Correct? This is why some people are going to University of Morocco. Yes. Yes. It's not depend. Some people are going to sleep. Some people are going to. But you can retrain your model, right? Your brain. You can train so that you can have a big thing going on in your journey, in your career. Yes. So processing, that's the part. So the processing is happening inside your brain. Now that's why the brain is intelligent, not the sensing, not the action. Now if you take a computer, then let's try to understand the intelligence of AI data. What do you get from sensing? What do you get? Yes, IIT, your IIT, right? Yeah, what's your link? Just when you're sensing, what do you get? Information, right? Okay, this young gentleman is the only one giving correct answers, yes? No, that's true. So what's your name?
Hume.
Huh?
Hume.
Hume. These days the names are like, it's very hard to say. Even at my classes, sometimes I say Nirmani, Nilmani, Nilkani, Nilrani. I'm like so confused. I just say, okay, this girl with a blonde hair and that's easy one. Yeah, Pumara. Huh? Pumra. It's a nice tongue twister, you know. You find a foreign chap and tell your name, Bugger will go, you die or something like that. So Pumra. Right, cool. So when you see something, you get information. When you feel something, let's say someone is coming and, okay, I'm coming and I'm stroking you like this. What would you say? But if I hit you like no! Sensing. Just see this also sensing, yeah. But you get an awareness of what is happening. So data, anyways, computers can retrieve data. That's not the point. So let's say you retrieve the data, you do something. That's what you do in ChatGPT. You don't know what the hell is happening inside. You're taking and you're putting into ChatGPT. ChatGPT, give me this. ChatGPT, you come to. ChatGPT generate this thing so that our lecturers won't figure out that it was generated by ChatGPT. You guys can give lessons on prompting also. So anyway, so sensing for computers are like this, right? You have sensors. Yes, yes, come. We were having fun, they were laughing, jumping. I was very hard to control the class now. And these people are coming in the middle. Loose. No, come. You're from Urugu. Where are they? IIT. Right, cool. Right, cool. So sensors are there. Sensors are the ones who are going to collect these data. So you have a lot of sensors. You have smoke sensors, you have video cameras, all these stuff are information. Still, it's not intelligent. Then these data, let's say you take the data, you make an output. No sense. There's no sense of the output because there's no meaningfulness in what you're doing. So the AI part, let's say we have data, we have information, right? We come up with an equation, mathematical algorithm that can analyze these data and give an output. So then this output will be something like this, yeah? The intelligent robot who's working. Now you understand these outputs are not intelligent. These data that you take is not the part that is intelligent. It is coming up with an algorithm that can analyze these stuff. That is here. So you're coming up with equations, mathematical equations. Writing some sort of neural network. You write a machine learning code, let's say, kill nearest neighbor, that neighbor, this neighbor, not the neighbor who next to you, like Jesus said, to love the neighbor. I know, but so what you're creating is a mathematical algorithm, whatever the training process that it goes on, it comes up with a mathematical function that can say, do something meaningful. Should be meaningful. Yes. So all these AI engineers are the guys who are coming up with different mathematical algorithms for different applications. Absolutely beautiful. It's like you're Einstein, you're Stephen Hawking. Stephen is Hawking. Ramanujan. Yeah. Ramanujan. Professor John Nash. You guys are like that. You guys want to become people like that. That is what you put as AI type. AI engineer, AI this thing. But actually AI means hey in Sri Lanka. Hey, I don't know why. I don't know why you say like that. But you should not state like that. You should be able to understand the gravity of what you're doing. What you're doing is you're coming up with an algorithm that can do something. So that algorithm should be perfect. Understood? புரியுதா? So are there any people who are Tamil? Tamil? Okay. கொஞ்சம் தெரியும். Please cope up with me, okay? Up to now, நல்ல. Oh, சொல்லுவேல இல்லடா, தெரியுதா? தெரியலடா, whatever you are saying, தெரியும், right? கொஞ்சம் தெரியும். For me also, Tamil, okay. If you want something, I'll tell you in Tamil, okay? So let's take this now. We understand what is the goal of AI is to come up with a mathematical algorithm that can analyze the data and give some outputs. Now let's talk about how this baby was born into this. Can someone tell me the birth of AI? Which year?
Month workshop.
Huh?
Month workshop.
Wait, I mean like
1983.
1983. 1953. You are deducting 30. Someone coming 1923. Can you please raise your 1953, then 1983. Young lady from Morocco. You remember India? And come. You tell something. Whatever the year, you can say 2026, I don't mind. It's okay. You have to share or not. 1985. Okay. So look, you can tell anything. At the back, so look. Something. You can't say I don't know and all. I don't understand. It's a tell a year, random year. You can say before Christ also, I don't know. No, you go to the crucifixion with AI. Hail Mary. You can tell whatever the year you want. I don't mind. So look, it's okay. No one is going to tell you that you are a muttal or anything. It's okay, you can share your knowledge. I don't mind. 1999. That's what now? 1999. 1999. So one guy said 1953. Why are you saying that specific number 1953? You're the ones who said which is going back to more than 50 years, more than 75 years. What do you call? But nowadays they are saying that 78 years of this, the curse of 78 years. So you're going back in time. Why are you saying 1953? That specific number. They understood about the AI in that decade. Okay. Why? Original idea was generated there. Cool. So if you take the actual number of AI, it goes before 1950. AI enthusiasts are 26 alpha generation or the beta, whatever they generate. Now you're learning like a concept that was built before 1950s. How, sir? How before 1950? Now only ChatGPT is there. All these politicians are saying, oh, we need ChatGPT, Gemini. Tapada. We have to understand that this goes back to 1950s and why? This is the birth year of digital transistor. Go back. Transistors. What is a transistor? There are A-level kids here. A-level. No one is from A-level. You are from what? A-level. After A-level. What is a transistor? You are the youngest guy in this whole group. What's your school? Good school. Now tell me, what is a transistor? We have a guy from the back. Yeah, it's a semiconductor. I heard you that part, but the other part I couldn't know. What does it act like? What does the transistor act like? Huh? Logical operator. What is the logical operator? You said it's a logical operator. Yes. That's a logical operator. What about monotone? What do you think about the transistor? What does it act like? Ah, yeah, from the back. Yeah, controls the direction of city goes to the direction of the direction. How do you control it? So simply, if you take a transistor, it acts as a switch on and off because of this semiconductivity. If you have to give a certain voltage in order to short circuit this thing, if not, it will be staying at open. So this is the birth, right? Isn't it true? Can't you derive logics? If this sensor is on, if that sensor is on, and gate, turn on the machine. Isn't that intelligence? The sensor senses something. It says to the logic gate, okay, this is happening. This sensor is also telling that some sort of a bad thing is happening. You go to that AND gate, this gets short circuited and get operating the machine. This is AI. We have been living with AI for our whole lifetime. Presence of AI was there. We didn't understand it was existing. If you take a remote control, you press the channel 1. Doesn't the TV goes to channel 1? Isn't that intelligence? Understood your requirement, which is to go to channel 1 and see what's up. Isn't that intelligence? The level of intelligence is different. I totally agree with you guys. This is the birth of AI. This is how AI was introduced to the world. So all these stuff, when you take people who have worked with Arduinos, can you raise your hands? One, two, three. No Arduinos. You know what is Arduino? What? Chickpeas. It's a wheat. Cardamom. Arduino? You haven't used Arduino? No. You have heard about Arduino? Yeah. You have heard about Arduino, haven't worked with Arduino. But everyone has written a program in your lifetime. Now don't say that you haven't done. People who have written a C program, can you raise your hands? Utara. You're Utara, right? Whatever there are. I'm extremely sorry, don't get offended. You haven't written a C code, Python code? Why? Yes. You're here for the first time. The workshop.
It's a workshop.
Yes, yes. Everyone is going to the back. I have to break the wall in the person is going to come. I can put it in front. So, you guys are writing some sort of a program, yes? Yes. When you're writing a C programs, you wrote who taught you C in your listen? At sleep, who taught? You are from sleep, right? Who taught? The lecture? Yeah. For you guys, Kamshika. For you? Salini. Salinda. Salinda. Okay. So when you are writing, they talked about if conditions. You wrote if else if. When you write those stuff, what happens? What does the compiler do? Compiler goes and configure all these logic gates. If this thing can happen, that do this thing. If these two conditions are going to make, do this thing. If these two variables are going to change, it's setting the whole logic gates inside your computer. So you have coded. You don't have to rely on ChatGPT. You guys were coding AI. from the first day you have entered the university. Or some people who have done programming during their A-levels. This is the birth of AI. This is how AI was introduced. To if else logic, fuzzy logic. Likewise, they were called rule-based expert system. Rule-based expert system. All these stuff we are going to learn about these rule-based expert systems a little bit in advance. This is how AI was introduced to the world. Birth of AI. Then, okay, that is the basic, the shallow end of the gene pool stuff. Right? The very basic stuff. So now what we are talking about, machine learning, deep learning, that learning, this learning, everyone is learning, you guys are not learning. Okay, what is the birth of machine learning? Can someone come up with an year? Hasif? They're talking about a very current trend, machine learning, deep learning. Okay. 1983. Okay. People were saying 1983. Can you raise your hands? Birth of machine learning. Any updates from you, young lady? IIT lady? Nothing. Tell a year me. Yesterday. You can tell it. Just think and listen. 2002? Yes. Okay. Actually, it goes back to 1950s and between 1960, as you said. Oh, wow. This is how this is the year that machine learning was introduced. So people had a problem. People had problems with these rule-based expert systems. What? Imagine you are writing a program to mass holding. You take a mass holdings, you are writing a software for it. So you are coming up with a software that can analyze all these conditions of the machines by looking at their sensors and their powers, consumption, whatever the inputs you are taking, you are writing a program. Now you know that mass holdings is no longer there. In another 5 years, mass holdings is entirely stopping their factories in Sri Lanka. You know this, yeah? No? They're shutting down their factories because of the power problem. It's very costly. So they are moving to India and Bangladesh. They're having their main office inside the BOI in Diagama, but instead of that office, other office of all the factories, they're in the process of shutting it down. Because this is a business. In India, 1 unit per unit cost is 50 cents. Not the 50 cents Hussein's, the candy shop, right? Welcome to the candy shop. Yeah, not that bad. 50 cents. But in Sri Lanka, it's 350 rupees per unit. 150 for domestic, but these are industrial ones, it's 350. So they are relying on you guys to come up with solutions, but you guys are not coming up with solutions. Guys from Moratuwa, Peradeniya, from Lunas, from SLIT, from IIT, IIT, SIT, that IT, this IT. You have the knowledge. But it's not sufficient enough to come up with a solution. This is why we are coming up with these cost-effective AI solutions for it. So making a contribution to make sure that these industries are not leaving Sri Lanka. Because and sustaining your job market. So just reading materials, just doing the exams is not going to help you anymore. You have to come up with solutions. So anyways, the thought was if you're going to for a different country to establish a factory, the power they use is different from Sri Lanka. The sensors that you use is different from Sri Lanka. The power rating of these machines is different from Sri Lanka. Let's say you're writing how many thousands lines of code. Each is connected to each other. Each and every code, one function after another function. If you change something like a chain reaction, it's going to collapse everything, like a nuclear bomb. That's how nuclear bombs are made, right? You are doing something into the molecular structure, like a chain reaction, it's going to everything breaks. Boom! Don't tell this to Donald Trump. He used it in Iran because he has it. Right? So this is what the chain reaction kind of a thing happens. Very hard. You'll lose your hair. You'll get old. Older than me. Okay. So you have to make sure that this is hard because this is a business. We have to make sure that our business is profiting. So, and we have to expand. You can't say, Ani, okay, I want to make 1,000 units. After that, no. You can't say like that. When the demand is increasing, you have to make sure the supply is there. So you have to make sure that you go to another country. So writing these programs were hectic. Adaptability. It's not adaptable. Takes years to adapt. Write and write, troubleshoot, write, troubleshoot, write, troubleshoot, write, troubleshoot, write. Industrial revolution is happening. Other countries are coming. And competition is there. So they wanted a program that can, okay, look at these stuff. Right, okay. We are telling what to look. And they adapt it for that. They wanted an algorithm like that. So then they came up with this thing called machine learning. We are going to learn about it in a holistic manner, in a comprehensive manner when it comes to machine learning part. So you should understand. So machine learning is like entirely, you are telling what are the features. What are the information you have to look into. Hari, can you increase this AC? It will be very because I'm acting and doing these stuff. Yes, here's how I do lectures and yes, I will. You find IIT, no lecture. No dancing. No. I have to shake the little boobies. Yeah. I asked them to. So yeah, anyways, the thought was how to come up with it. So we are telling, okay, we are telling the algorithm. Algorithm, these are the inputs that you have to look into. These are the features that you have to look into. These are the things these are the sensors that you have to focus on. Then come up with an algorithm adapting accordingly. So even if you go to Bangladesh, you know what are the sensors to look into. It will automatically fix it by looking at whatever the information that is coming into the system. It's training itself. Algorithm part is now automated. Now, no longer people coming up with the logic. We are writing programs that self-generate algorithms. All good. Then, what is the birth of deep learning? So now you have machine learning. There are problems in machine learning. We're going to talk about. Now tell me, now we have machine learning, no problem, everything is getting adapted accordingly. Yes, everything is fine, everything is nice. Why do we need deep learning? Something else we'll talk about. But what is the birth of the deep learning? What is the year? At the back. No idea. 1970. Because it goes like 1950, 1960, 10 years apart. Now it's like, lucky guess is it? It's too much for you guys, no? Have to show a lot of facilities are available at Sleep Plus. Shamelessly marketing the place. වැඩි කර ඒ කියන්නේ මට AC එක වැඩි කරන්න.
වැඩි කරගන්න
ආ.
වැඩි කර.
වැඩි කර. ඒ කියන්නේ සීතල වැඩි වෙන්න ඕනේ. රස්නේ It's very confusing, no? When we are saying to increase the AC, are you trying to increase the temperature or are you trying to decrease the temperature? If it is like decreasing the temperature, which means like another, it's a whole lot of a mess. AI is figuring out AI is easy. There is the person to increase the AC thing. Yeah, okay. So machine learning. So your A-level student, after A-levels, you are after A-levels, I'm talking about the back first. First year, what's the university? Huh? Okay. Epic. Right. Epic. So he said 1970s. Any other guesses? Lucky guesses? No lucky guess. Okay. There are no lucky guesses. It goes back to 1960s to present. 1960s present. So why do we need something like this? Now what is the catch there? We had, when we started in 1950s, algorithm was developed by us by looking at it. After 1950s, the algorithm was automatically generated for the information that we told them to look at, or the features that we asked them to look at. So what is the remaining thing to get automated? Selection of features. That is what deep learning is. Now, in machine learning, the features are things that we tell them to look at, aspects of. Imagine a person from University of Murtu or Murtu. What's her name? Huh? Devanti. Mevanti wants to make an also. The Apeksha hospital is asking Mevanti, you have gone to Dr. Ushar's workshop, you have a good knowledge in AI. Okay, you are asked to develop a model. For what? For early cancer detection. Okay, I know machine learning. Ushar sir taught us machine learning, so let's write a machine learning program. So, Nevanti is the one who's going to determine what are the features. Yes. So she can go and consult a doctor. Let's say blood thickness, whatever the parameters you are going to say. Let's say you are looking at only 3 parameters. These are the 3 parameters that you have to look in a person. Unfortunately, there's a rare feature that even Sri Lankan doctors doesn't know. That we get from that contributes for early cancer detection. Yes, her one is running in Apeksha as a university, production of University of Morocco, Neman. And people are going, using Neman updating, Morocco, the cream of Sri Lanka is that. And going, putting the finger, not the finger into the side. You take a blood test. Cancerous, no problem. Yay, I've got cancerous. She has forgot to put a feature. After 2 years, cancer did. Another person coming, putting the finger. Come. popping the finger and going. Yes, we were gone. So putting the finger. Cancer. At the end of the day, he doesn't have cancer. Because of the chemotherapy, he's getting cancer. This is where, even though we laugh at this thing, it's a very sensitive. So, as AI engineers, you have to make sure that whatever the algorithm that you're developing is perfect and looking at all the aspects. This is a problem. As a human being, Nevandini, right? Nevandi can't look at all the aspects. Yes, we can talk with professional experts and domain experts, top doctors, after another doctor, after another doctor, after another doctor. But still will fail. Therefore, they came up with a technique, understanding this overlooking part, where the features also can be automated below. That is what deep learning is. So basically, if you give a data set, that is why people say that it's a black box. So people are writing the neural network and trying to find the black box. Black box part is we don't know what are the features that it is getting learned. What are the features that we are trying to make it prominent? So then whatever the information you have, you put to the neural network, the deep learning neural network. It will learn and figure out what is the thing. So even a subtle change can do a big thing. You have heard about the butterfly effect, right? Yeah, flaps of a butterfly in Sri Lanka can make a hurricane in US, not in US. They will bomb us in the UK. So Canada order. So you see, so deep learning is a very beautiful thing that is also automated. So when you look at this thing, what is the difference between these three? One decade after another decade to another decade, what was different? What do you think? Everything is artificial intelligence. But what was the difference between artificial intelligence and machine learning? And from machine learning to deep learning? The level of intelligence. So guys, you have to understand that we have been living with AI for our entire life. Even half of your parents have been. My grandparents, I don't think so. Some of them are dead. 2 of them are remaining. They're experiencing AI. That's why they're like monkeys, putting all the posts every year and repeat. Right? So I have to understand that. So the level of intelligence is the thing that differs. So if you take artificial intelligence before 1950s, it's like a snail. You can't say snail is not intelligent. If you poke the finger, does it go inside the shell? Goes, right? That's all we can do. Then you can put him to a salt water, and then bug dies. But machine learning is not like that. It's like a chimpanzee. You go and poke this guy and see. You lose a finger. And deep learning is like us. Like Chavka. So you can see that you can poke the finger, but you can keep the finger, but you'll get hammered in a different way. So you understand that the level of intelligence is the difference between these algorithms. Very interesting. Very interesting. No more than that. Okay? All good? Cool. So far, so good. You guys missed a lot. You can ask from Nevandi. Yeah, wow. We're talking about Nevandi. Oh my gosh, so much of actions. So let's talk about artificial intelligence before machine learning and deep learning. So basically, we spoke about what we have to sense the environment. So they were called rule-based expert systems. So the input for these systems were sensors. Any sensor can identify it. can be moisture sensor, that sensor, this sensor, whatever the sensor. Why sensors were developed? To understand environmental phenomena. To get a signal, right? When you heat it up, some sort of a temperature sensor, you'll see the voltage is going high. When you cool it, you see the voltage is going low. To understand heating and cooling. If you take a light sensor, you flash it up, you will get a high signal. If you take off it, it will give you low signal. Environmental phenomena is understood. Moisture sensor, all these sensors understand what is happening in your environment, converting into a signal which can be analyzed, quantified. Now the problem is not in Sri Lanka, but in all the people, we can't quantify what is coming into our heads. Yeah, we can quantify some amount. That this guy is dark and this guy is fair, or something else. But proper quantification, subtle changes cannot be identified. But these sensors are developed so that they can identify this. So whatever the signals that you are retrieving from these are captured and processed inside these microcontrollers or microprocessors. Atmega 256 and whatever the brain chip, the board that you're using, the computer is going to retrieve this thing, understand how these fluctuations happen. It can capture, right? It can quantify whatever the then what can you use? You have to use rules. Rules generated from if, else, fuzzy logic, decision trees, goal trees. These are like the beginning of rule-based expert systems. Were first of all, if else. Then they thought, oh my god, if else is like entirely one and zero. Either you like me, you don't like me, you kill. You split it. That's what you do, right? Nowadays, how many people have died? You go and tell a beautiful girl, I want to marry you tomorrow. If she say no, you kill. She say yes, tomorrow get married. This is a little bit of dangerous. There should be a gray region, right? Have a period where you understand the person, the gray region part. That is how the fuzzy logic person. Then decision trees, goal trees, these kind of different, a little bit sophisticated algorithms were very understandable, adaptable algorithms were introduced. But still, these are rules. Rules that you make. Good. Then from these rules, you can take an output, you can make a home automation system, industrial automation system, whatever the automation system you can make out. This is how AI was introduced. According to that, all good? Cool? Good. So let's try to understand how logic gates and AI. So let's take this house. No one is here. What sort of things can we use to detect this thing? Forget about cameras. Cameras is a different ways of analyzing this thing. That is why machine learning, deep learning was introduced. But still, you can use computer vision and do it as well. But since you guys are still basic people, we'll forget about the camera part. How can you sense there are people or not? Yes, good. University of Moroto at the back. What's your name? In the middle. Imash. So we call like this in our place. Imash. How do you sense this thing without a camera? Motion. Very good. Very good. You use a motion sensor. Then let's say a burglar is looking at your get to try to come into your house. Can see no one is there. How can we identify if a burglar is there? Okay? Himash. Huh? Distance sensor. This is a motion sensor. Distance sensor. Why you don't want to use the same sensor, no? Why? When you have different varieties, that is how this thing. A girl can eat bad, emission, there's difference, yes. Can't you use the same thing? Use another motion sensor? can, right? We can. But the problem is in here, how do we figure out when you don't have motion, what is the output of the motion force? Let's take it as ones and zeros, okay? Don't think about the volume. Zero. Zero. So can zero activate something? Then we have to invert it, right? So if someone is not there, we have to figure out whether that person is not there. So we can invert it. You throw a not gate. So let's take this thing. Okay, now let's take this thing. So if you to put this thing to an AND gate, you can fire up silence. Whew, 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 whew. Then the monkey is not looking at it. No, it is wrong. Isn't this thing intelligent? Are any human involvement? No. Entirely logics are the ones who are doing the process of a human being. You have created intelligence, artificial intelligence, man-made intelligence. Voila. This is how the birth of. So if you're in first year, fundamentals of programming, AI, foundation of digital design. You have foundation of digital design. Are you from the engineering faculty or you are doing electrical and electronics? First year. Second year. Mechatronics. Yeah, don't you do foundation of digital design? Digital electronics. You did. You think it will come. Okay. When it comes, you know some. Okay, so finite state machines, this kind of stuff, these are the ones. They are creating intelligence. Very beautiful. Very beautiful. Very beautiful. Good. So then we talked about the reasons why these rule-based express systems are not good. One thing is not adaptable. It's consumes a lot of time. Does not learn from the previous mistakes. Resources are wasted. So because of that, only we had to move on to machine learning. I think you guys missed that part. Yeah, you can ask from. I'm now like a monkey telling a name. Netandi, right? Netandi. Nevandi. Oh my gosh, if I'm like 29 and I'm having these issues, imagine when I become 70. I will totally go for a dementia kind of a place. Yes. Okay. So let's talk about machine learning and these stuff, right? So what is machine learning? How it was born back then. So I will show you a picture right now. Do you know this person? You know him. You know him? Just keep it with yourself because you are always doing something. You are from what school?
I'm from Ambalandra Therapy.
Therapy. So you are a very religious guy. Huh? Just the name only, you're not religious. Okay. I don't understand what I'm telling you. Good. Okay. Anyone can tell this person? Himanshu. Himanshu's friend. Don't know. Very odd kind of a person. Say something. No, you don't know. What about you? I know him, but the name I don't know. You have seen him walking around the corridor. You have seen, at least you have seen him. Good. Any, you know? Don't know. Good. Okay, tell them.
Alan Turing.
Very good. Have you heard another called Alan Turing? You guys have. Heard the name. What about Moruto? You guys even never heard the name. Okay. That's pretty odd. Alan Turing. This is a profound scientist. This is the guy who gave birth for art machine. Very beautiful. Very beautiful. Yeah. This person died when he was like 38. Imagine if he lived for 70. Today we will be going on the cars that are flying on the sky, hovering on the sky. He got accused. Very sad story. You have to watch this movie. There's a movie called Imitation Game. Imitation Game, have you heard about it? Yeah, watch it. Not watched it. You have to watch these movies. They talk about Alan Turing. Because of Alan Turing only you are staying like this. Because he's the one who made a machine learning model to fully machine learning model in to break the Enigma. Enigma was so you guys have heard about encryption, decryption type of stuff. So Enigma was a encrypting machine. German messages, all are encrypted. Very hard to. It has billions of combinations to encrypt the message. So all this stuff was possible to crack that message was possible because of this guy's mission. Very beautiful, right? So if you take, you have to read this paper. It's called Computing Machinery and Intelligence. This is the very first paper which was introduced by I think it's like commercials. A commercial bit. Yeah. So you have to read this one. 12 pages of pure beauty. There was a problem. He was once asked a question. Can a machine be intelligent as a human being? Can it be intelligent as us? Or is it beyond our intelligence? He was asked the question. He put it in beautifully. Obviously, machines cannot be intelligent as us. That doesn't mean that it is not intelligent. You like Himanshu likes what? Something cake. I don't like cake. I like strawberries. That which means I'm more intelligent than he. So if you think that okay, Tushar sir is intelligent and I have to eat strawberries to get intelligent, what a stupid thing. Our level of intelligence is different. But still, that doesn't mean that that person is not intelligent. And he was asked, okay, if there's an intelligence like that, how do we test it? We don't have a test to test if the machine is intelligent or not. So in this paper, he has beautifully talked about the test called the imitation game. Very beautifully he has explained. So he said, okay, let's make a machine which is intelligent, can speak. You put the machine into one room, you have a judge and a human being into another room. All three people are in three different rooms. Let the machine talk, say hello, then a human talk, hello. Then the judge should listen to the audio and figure out whether which one was the machine, which one was the human being. So let's say when you're saying hello, both are here. Goes to the next step. I am Tushar. He said, this is the machine. Then you will ask the question, why did you say that it's a machine? Because when he was pronouncing Tushar, there was a mechanical part. It's like entirely mechanical kind of a sound is coming. So then he fixed it and he repeated. You do mistakes, you learn from the mistakes, you do mistakes, you learn from the mistakes, you do mistakes, you learn from the mistakes. This is the process of training in neural networks today. Is that true? We're going to learn those stuff. This was introduced by this man. Unfortunately, he had to die when he was like 40. Because he was accused as a homosexual person in the UK, not like now today. Homosexuality was banned, and it was a you get a lawsuit for that. You get accused and you have to go to prison. This guy named his machine as Christopher, his first lover. His first lover died due to leukemia. And he made a, so he wanted to build a, it's because of that only you are talking about machine learning today, deep learning today. He wanted an intelligent machine who acts like Christopher, so he can start loving the person. So he made sure that his machine is entirely human. So he was told to go for 2 years of prison or take hormonotherapy. So he thought, so he took the hormonotherapy. When he was asked why did you choose that, if I go to 2 years of prison, who's going to take care of Christoph? Who's going to build him? Who's going to make him intelligent? And he died. You are using apple, right? You see a half-eaten apple, right? A quarter-eaten apple. He died by eating a quarter of apple. That's why they are putting the logo in behalf of respecting this man. So he put cyanide into the apple and he ate. And he died. That's the apple that you're using. Even I understand. Very beautiful. This is the birth of machine learning. This guy is wonderful. You read his papers. If you want, I can give you the paper. Yes. Read it. Absolutely beautiful. The explanation they have given. Got to read, guys. You guys are university people. You guys are here to use the people who are trying to go into a university. You guys are here not to just pass exams, but to learn about the universe. We can't teach you the whole universe within 14 weeks or within a semester. How can you? I'm not Brahma or some sort of a god. I can show you those. You have to go and read and understand. These stuff was not taught in my PhD. I have to read there and understand. Great. Understood? This is the birth of machine learning. So, okay. So, let's try to understand how machine learning works. Yes. Can you differentiate these two? Yes. Who's in the Himanshu? Who's that? Ah, good. You understood that it was a dog. Yeah. Good luck. The below one? Okay. How did you figure out that it's a dog and a cat? What did you go through? When you looked at it, what did you saw? Yeah, sure, good. Yes, you told the answer. What did you? Face, the shape. Home here. Even though Dhammika Perera slinged mediocre, actually it's a fact. But the problem is the way he told was wrong. The structure is one feature that you look in. You know that texture is unique for you. For humans, you have a unique texture. Not the color, the texture. Right? Humans have a unique texture. Even you have a unique texture compared to me. This is how you can learn about this. So one feature is that. One feature is texture. Then color. Actually, that is the black color dog. This is a brown color dog. But the problem is these big people are paying half of the money. So projectors are pretty cheap. No. They are paying the full money. You are paying full money, right? Our guys are very cheap. So see, it's a black color person and a dark color. So if you take the features, the inputs, selection of features, one thing is you can tell the color of the animal, the shape of the animal, and texture of the animal. So you take millions of photos of dogs, millions and millions of photos of cats, and if you record their values, right? Record their values, like what are the colors they get? What are the shape values you get? Texture values you get. you will find these kind of distributions. Very, very beautiful, right? Super, right? So the machine learning is to come up with a line that separates these two clusters. That's what it is, nothing else. So the algorithm, whatever the algorithm that you're saying, it's just a line that's separating clusters. Clusters form because of what of information. Pretty beautiful. Beautiful. So after this k nearest neighbor, whatever the neighbor or the support vector machines, you will get a node function that separates these. Then let's say now once you come up with this function, the algorithm or the line that separates these two clusters. If you give a new value, let's say shape this number, color this number, texture this number, you are looking at the distance to that line and figuring out which side you have come. Have you gone towards this part or this part? Absolutely beautiful. Absolutely beautiful. So whatever you do, whatever you write, whatever you do in your laptop, when you're writing your whatever the machine learning or the deep learning code, the output is a line that separates information. They are looking at how this point in the tree. These are it is only 3, but if you take features like 4 or 5, I can't plot. Right? This is hypothesis. We call it a hypothesis because there are hyperparameters because you have so many parameters you can't plot it in one. So that's why we are calling hyperparameters. Because of that, a hypothesis is coming. Hypothetical thing, assuming and doing. So you are generating some sort of a algorithm that you assume that it will separate. Absolutely beautiful. Absolutely beautiful. Okay. So good. So if you take types of machine learning, you have supervised learning, unsupervised learning. If you take supervised learning, you have binary classification. What do you mean by binary classification? You say yes or no. Multi-class means yes or no or maybe. Maybes are creating unnecessary babies. You see? Isn't that true? Let's say you going and asking out a girl. And if the girl is giving maybe looks, I want him, I don't want him. I want him, I don't want him. I want him, I don't want him. Problem. He is not moving forward. Unnecessary. But in life, you don't have these perfect solutions because you have to have multi-class. You have to say this is a cat, dog, elephant, whatever the animal. It should be multi-class. So if you take multi-class, there's multi-linear regression, multi-level support vector machines, k-nearest. If you take unsupervised learning, again you have binary classifications. Linear regression support, and also multi. So you can see that the machine learning part is divided into 2 parts: supervised learning, unsupervised learning. So let's take this supervised learning. How does it work? If you take supervised learning, what do you mean by supervised learning? It goes back to your schooling. You need a time off. Okay. You can take a break. Yeah, now you're great. Shall we stop from finishing of machine learning, then deep dive? Then we get straight away. Shall we finish machine learning part and take a break? Okay. Good. Are tired? I'll make you laugh like that now. I am the one who should be tiring. I'm jumping, I'm doing, I'm hopping, my back is also paining because I'm doing this. Right? Supervised learning. It's like entire schooling. And you remember what school did you go to first? My school. Super great. Who did apply for you guys? Pushpa Kumar. Pushpakumar himself. Yeah, you did your A-levels at Royal? Yeah, who did applied mathematics? Ah, Vimal. Pure mathematics. Pure mathematics. There was a matter. Thank you. You understood the gender. So those days we had Pushpakumar sir. Was a singer. ගණන් දෙකක් අතර වැඩි පාස්සේ. වැඩි කරන්නේ නෝ. Thing is, but during our schooling days, if I applied sir yesterday, the projectiles. What do you call in singer projectiles? Yeah, the practice shift or whatever. Yeah, again, I'm not right now, so that has not given me something. But the problem is now it has been so a couple of years now, 10 years of being in school. So, and delivering these kind of stuff, and now my knowledge in those terminologies is not no longer there. So when you're saying that, okay, when you're drawing, when your master is drawing the projectile like this, if you ask why sir it is like that, why can't it go like this and come like that? Shut your mouth and wait. Whatever happens, it's like that. Why, any problem? Get out of the class. So you are doing the thing like that. That's all. When you write the R's and the A's and the B's and C's in schooling, very small days. Sometimes I wrote my A like this. I don't have a marker. Right? So I wrote the A like this, B like this. What will happen? What are you put it inside this thing, you do like this, you do like that, then you do like that. That is A. After that, I'm not writing A's like that. What did we do? We chose them, some people. We can train it. And the objective is for them to learn it properly. That is what supervised learning. That is A levels. Until A levels, that is the same. Which is a very bad way of learning. You should admit that. That is why the curiosity is sucked out of your system. If you go and ask now, so when I went to these smaller kids, they asked some profound questions. Why the grass is green, the moon is round, why grass is green? Why grass is green? Huh? Chlorophyll. Okay, why do we need chlorophyll? Very good. He has asked why grass is green. So they are asking a lot of questions. Then you learn something. The problem is because of this training mechanism, you are not asking questions anymore. Yes? In lectures, I feel when you go to abroad countries and teaching, they ask so many questions. I told you, why are you dressing like this? Why are you shouting? Why are you laughing? Why are you jumping? Even those kind of, that is too much of personal questions, but they ask so many pretty nice questions. So you have to ask questions. Okay, good. So that is supervised learning. Sometimes we need to keep the control of our model. Make sure that look into this, look into that. Your duty is. That is called supervised learning. So basically, you have the training data. You have a learning algorithm. Then you derive your hypothesis. The non-linear this thing that you have, hypothesis. Then you give some sample data and check whether the predicted output is coming properly. You generate this hypothesis, you put it and say if the output is wrong, you retrain the thing. Again take the hypothesis. You put it, validate it, no. While the cycle rank up until the loss is very small, you do it. Very strict, very neat, right? Very neat. So if you take, so these are some supervised learning stuff. Oops, yeah, these things.
So I want you to look into this.
What could be more frustrating than wasting time stuck in traffic? But imagine a future where you could read a book while a computer takes the wheel. As Dick Wilson explains, the era of automated driving could be just down the road.
Pull up alongside a vehicle of the not-so-distant future and take a good look inside. Researchers call them smart cars, and they could give the phrase backseat driver a whole new meaning.
That's the goal, actually, of the automated highway system, is to allow a commuter on his morning commute to sit back and catch up on work, make phone calls.
Scientists at Carnegie Mellon University have been building prototypes of automated driverless vehicles for the last 10 years. 5 years ago, the vehicle, dubbed NavLab 2, was a bulky Humvee loaded down with cumbersome computers and camera systems. The gear enabled a computer program to see the road. Today, NavLab 5 is a streamlined package that fits into a sedan, and its systems can help if there's someone at the wheel as well.
These vehicles here are designed both for automated steering, like the Humvees, but also to monitor human drivers' performance, to warn them if they're going to get in an accident. So if I start to drift to the inside, it'll trigger an alarm as soon as one of the tires gets outside the lane boundary.
The system relies on a small video camera inside the car to see what's going on outside. It looks for lane markers on the highway to help keep the car and the driver on the road. The camera's mounted just below the rear view mirror, and it looks at a trapezoidal shape 20 meters ahead of the vehicle. The image is analyzed by a portable computer workstation mounted inside the car, powered by the cigarette lighter. In a test last summer, a NavLab van traveled from Washington to San Diego. More than 98% of the trip was driven and controlled by the computer. Just about everything but the brakes. But there were some bumps in the road.
It has trouble in situations that human drivers sometimes have trouble in also. One of the most difficult situations is a rainy night with oncoming headlights, sort of blinding you because of the reflections off the roadway.
Researchers expect it will be another 10 years or so before they get all the bugs worked out of an automated driving system, but the accident warning program could be added to existing vehicles within 2 years, initially to trucks, which researchers say have a high accident rate.
1 in 4 heavy trucks are involved in this kind of accident within their operational lifetime. So it would be a monetary win for trucking companies if we could sell it for $2,000.
The goal is to make the highways a little safer by keeping an extra eye on the road and one day 2 hands off the wheel. Dick Wilson, CNN, Pittsburgh, Pennsylvania.
This is sorry.
If you want to learn how to master using AI, don't watch.
We have recently built the NavLab, a test bed for research in robot navigation, image understanding, and the role of human interaction with intelligent systems. The NavLab is a roadworthy truck modified so that researchers or computers can control the vehicle as occasion demands. As a mobile navigation habitat, it accommodates researchers and significant computing on board. Because it is self-contained, the NavLab is not subject to telemetry bottlenecks, communication faults, or dependence on stationary infrastructure, and can travel to confront navigation problems at a test site.
So guys, this is a 1996 project. Actually, it uses supervised learning. So machine learning was used to do this thing. So what is unsupervised learning? What you should do in the university. We are not supervising. We are giving you an awareness. You should learn from your mistakes. That is what unsupervised learning is. So you are creating algorithms, giving an objective to learn for a different part. You are giving awareness. But it will learn, it will self-train from their mistakes and coming up with solutions. That is unsupervised learning. So this is a small example for unsupervised learning. So you can train a model, let's say, forget about the CNN part. Let's say you are coming up with a machine learning model to detect adults' action. How adult moves. Let's say adult is sitting, adult is entire trained for adults only. and you're taking and implementing on children. Totally different, right? So children are so little babies who can't figure out the hands and the face and the choppy face on the, I don't know, squishy. But still, it will learn. Yeah, that is one. Then there's another example. So this is called auto-encoded based data clustering. Right? So what I did, this unsupervised learning method was created by me. And it is published, so you can check if you want in Google Scholar. But the thing is, what I did was I trained this model to repredict the motion. That's all. But from the extracted features, I clustered and I saw. So my data set, the original data set only consists content. So my objective is to determine if the child has abnormal, if the child is abnormal or not, right? But the data set was also collected like that. Okay, these videos are abnormal, these videos are not abnormal or typical. When I did this thing, I saw it's go beyond that. It's not only typical or atypical, typical or atypical. There are intermediate behavioral clusters coming out. Doctors, all these doctors were amazed because they couldn't see the subtle improvements. From this model, it was able to figure out, okay, subtle improvement is there. Again, unsupervised. Unsupervised learning is everywhere. Even when you are using ChatGPT, when we give prompt something, doesn't it ask, is it good or bad? You may take it as good, but it is shit. Right? Sorry to say the shit, but the actual thing is that you think, Guru is ChatGPT, but no, it makes mistakes. So you have to tell it whether feedback is correct. Then he can, if it is bad. Now, one time, one of my students, what he has done is he has given ChatGPT the report, the thesis, mentioning that. So he has generated the whole report through ChatGPT, and it's saying like very like even like if the queen was if the queen read this thesis, she will resurrect and die again because that perfect. So he has told that, okay, ChatGPT change this thing so that the lecturer won't understand taking off these complicated words out of this thing and generate the thesis. ChatGPT did it. He didn't proofread it. He said, okay, give them. I was reading this whole thesis. The research is all about some sort of a signal analysis. Okay, so I was reading. This thing is telling heartbeats. I was wondering if it's taking some sort of heart related disease. No, it's a sound wave and doing something. So heartbeats. All the pulses have been converted into heartbeats. Fail. Yes, sir. They do mistakes. They don't understand what you are doing. You are more intelligent than don't depend on these stuff. Yes, I also use ChatGPT sometimes. No, not sometimes, most of the time I use because to refine my English. Sometimes, not more all the time. I learn. Okay, let's say if I'm not a person who was born and raised in UK. I just went to UK for my deliveries and everything, for my research stuff. But sometimes when you are using vocabulary, even the foreigners, the Suddas in those countries don't know what ChatGPT is generating the words. The vocabulary is good. When you have when you see a crow and you say raven, it's like a question or something like that. Some vocabulary to improve my vocabulary. I use ChatGPT. But you guys are entirely depending on this. Don't. It's idiot. It's an idiot. So you are the one. You're the superior. So, anyways, so the basic machine learning model is the regression model. You have used this thing. Y equals index, the separation, right? So y equals index plus c. So by looking at the distribution, you are fitting a line. Can you remember your A levels? You did it. by looking at how the data points are going to lie, and you're coming up with a y equals mx plus c. Yes, that is the least thing that you can come up with. Right? So I told you this machine learning, what can you change in the y equals mx plus c? Yes, sure, correct. What is you correct? You said it. Very good. Gradient. Why? When you take the y equals mx plus c, y equals mx plus c, c is a constant. Let's forget about this part of for now. X is the information, y is the output. The only thing that you can change is what? M, the gradient. So how do you change the gradient? Gradient tells you, is it like this, is it like this, is it like that, something like that. Yes? So when the theta is changing with time, it changes with time. Yes? How do you do that? By looking at the loss. You draw a thing. I told you, you think that okay, this separation is wrong. You tilt it a little bit here. Change in the gradient. You always change the gradients and come for each and every. So this is the loss is determined by using a thing called gradient descent function. So we are trying to change the gradient by looking at how the loss is going to get low. Basically, you have the features like that theta naught, theta 1, and you are going to change the gradients and see what is the loss, the minimum loss that you can achieve. What are the two gradients I can come up to, depending on the number of features. Let's say in this case only one gradient. So this is called the gradient descent. So all these functions are learning from their losses. Okay, this is good. So basically, when the initial training is starting, you start from a very high loss, then you start to go down, and then you reach the lowest loss. That is the training process. You are figuring out what is the appropriate gradient that can be given for your function. Then that gives you that. So your ultimate goal is to come up with what are the gradients. The number of gradients depends on the number of inputs that you are giving into the system. Higher the number of gradients. So let's say my system has only 2 inputs. So these two, but then when I reach this thing, when I reach the lowest loss, what is my gradient value for that? What is my gradient value for the other? Okay. This thing is done. So next, let's take a break. Next step, when you're coming, let's program it. Okay? You'll take a break. Don't take a break also. Let's continue, sir. Take a break. It's okay. How's the session? Good? Bad? Is it good? Bad? Oh. No. And it's good? Maybe like, or maybe how is it good? What good? Good. Okay, you guys can have a break. We'll go out and see speed. Amazing, right? So guys, you can see technical. Excuse me. So we are this okay. So if doesn't have to be your responsibility, the people who are doing a paid degree, it's your responsibility to make sure that the money that has been spent on you is but entire lot of money that your parents are spending on. I see all these fancy laptops, all these big things. No, you can keep it. That's not the point. Okay, I hide the laptop part. That's not the point. The point is what's the university? Click. What's the school? Huh? What? What's your school? Rahul. Mother Rahul. So see. Good idea on that. Anyways, he's like, okay, shall I start or shall I leave? Right. So that's that. So we learned about these things. So shall we start writing a small code and see? So oops. Gosh, that's because puta, incognita and no. Notice. No, I can't see what is that. Right, cool. So basically, in this code, what we are going to do is we are going to come up with the linear regression. So this lucky guy got an example. You guys get it. I asked him to share it. He said, "No, I'm not to eat it." Okay, then eat. So basically, what this code does is like gives you a basic understanding of linear regression. How are you going to render the thing? First of all, you have to analyze your plots and say like, now let's say this is just a distribution scatter plot, but what I want to show is not this. So basically, our objective is to come up with a line that separates the two. But where's the code? Okay, starting from here onwards. Now, so in Python, people who are good knows Python, can you raise your hand? Guys have seen a Python? You know Python? But you looked at this time, why should I be the outcast? No Python. Everyone knows Python. Python. Okay. So in Python, Himasa, you know Python? Good. So you know Matplotlib, right? What is Matplotlib? My question. What is Matplotlib? That's good. So the in Python you need to plot something like graphs and all. The library is the Matplotlib, right? So in here onwards, whatever the plots that we are trying, if you want to draw a plot, we have to call that class, this whole class. So instead of remembering this whole tag, it's better to have a variable. We are using it as TLT. So if you want a bar chart, TLT.bar chart, TLT.line, TLT dot something, whatever the chart you want. Then there is this thing called NumPy. What is that part? I know I have a banana pie, is apple pie. What is this part? He must use whatever the pie. Yeah. So NumPy is numbers in Python. So if you need arrays, you know arrays, right? Arrays to save data, 2D arrays, 2D matrices, or single matrices. Those kind of facilitation. So in order to facilitate these kind of stuff, we have to import the NumPy library. But if you want, let's say NumPy.array, if you want to create an array, you have to put the NumPy part and put dot and it's a hassle. So in order to ease it, we just put NP. NumPy. Then after that, we can say if you want some utilities from the NumPy, you just put NP dot whatever the utility you want. Then there is another library called scikit-learn. sklearn, sciencekit. Right? Inside the sciencekit, you need a data set, right? Obviously you need a data set. So there's the science kit library first contains a set of data sets. There's a diabetes data set, there's a different data set, MNIST data set, different data sets. So you have to call that. So you have to import the data sets, whatever the data sets you have, import it. Then what are you trying to make? You are trying to make a linear regression model. So in the scikit library facilitates this function of coming up with a adaptive linear regression function. So therefore, for that you have to import the linear model. So so I told you this learns from what? From mistakes, errors. So you have to calculate the error, right? What is the error? Then you fix it. Then you check whether the error is getting reduced. That is what the main objective of training. Make sure that the loss is this. That is why you are doing an exam, right? First exam 30, second exam 60, third term 90. If you go other way around, you will get beaten. Then when you end your school, if you are getting all bad grades, I don't know what will happen. But anyways, so you learn from your mistakes. If you don't learn from your mistake, we call it you guys are idiots. What is that? Good. So that is what that is. So then you have to load the data set. Okay? So we need a data set. So what we are trying to do is we are going to look at couple of parameters and figure out whether the patient is having diabetes or not. How many people have diabetes? You have an answer for all the questions. Okay. That's very unfortunate. Okay. Okay, right? Then these days, anyways, I know some couple of students have diabetes. You don't go to the gym. Now go, now too late. Yeah, so guys, stay healthy. Have to go to the gym. I don't know whether you guys have seen me. I have 2 days per week I go to the gym. I go swimming. The remaining 3 days. Six packs in doctor I also have 4. You are family pack people. All the 6 packs in one package. No. Be healthy, yeah. That's the hardest. Right? When you go to this thing, you get the 6 packs and your chest and the biceps and triceps. Looking hard. Nice. So, my friends, all are like fathers. Now they are 29, close to 30. Fathers, I'm like their child. I'm wearing small things. So this time when a big match from my team, they are giving merchandise, like that t-shirt. So I told I want a small one. Team now. The buggers are put XL, double XL, and there's only one this. But you are buying this thing to your child. Jealousy badala. Yeah. So anyways, the diabetes. Moving on to this thing. So basically, so you have to load the data set. So I told you from learn there are a couple of different data sets. But in this case, we are loading the diabetes data set. And we are returning whatever the X values, whatever the diabetes values, and the Y values. So you have to, because you have to predict the label and the data information. So it's a 2D. Okay. Yes. Now, now you have to take the diabetes, whatever the diabetes, you have the X values. Now we have to split it, right? A set for training, a set for validation purpose. You don't train the validation, so you keep it apart. You train it for a set of data, then in your validity, you are taking that because you haven't involved those information to your training. Let's say you train the whole thing to this thing and you are again retesting on the data set. Anyways, it will predict 100%. So you have to train separately. So you have to separate your data. One set for training, one set for testing. So that's what I'm doing here. So all the information in Excess for a set of set is dedicated for training, a set of data is dedicated for testing. Then what are the appropriate labels or whatever the Y output? A set for the training, the relevant Y output. For the validations, relevant Y output. So we are separated. Now we have testing and training information. Then so now we are going to take the regression model. What? A linear regression model. We are going to save it. This is the model. Starting from this one, we are saving it to a variable. So when you are calling the model, the name of the model is REGR, regression, short term. So that model you have to fit it. Fit it to what? For the training diabetes X data, and they are good. How to girls? There are a lot of nice, beautiful girls. From script only, I figured out no beautiful girls. One day, another, it is going away. Now I like ugly girls. You can't do stuff, huh? But I'm gonna sue you. Right. Good. So for fitting the model, you have to give it to train data, right? So the training X data and the training Y tables. So you are training to predict whatever the thing, right? So after training, you are checking whether the predictions are correct or I can't give the same question. So okay. So now what you're doing is now your training part is done. Fitted. Great. Now you have to validate your. So for that you need to have the testing information. When you test it, so you set it to the regression model. Inside the regression model, you have said predict all the labels that are coming into the diabetes testing and check. Then you check whether the what is the error and you figure out whether the training process is correct or not. So basically, when you go there, I'm not going to. So you'll get a line like this. That's all. So that's linear regression. Right? I'm not going to go for like a simple support vector machines because we don't have enough time. We have to quickly move on to the deep learning part. Okay? Good. Any questions? So I will share this thing so you can go home and try it out as well. Okay? I'll give you some more things like k-nearest neighbor stuff as well to Harit, right? Hasit. Okay. Right. Moving on. Now let's talk about why deep learning. So I told you this question, the answer for this question. The deep learning, the difference between machine learning and deep learning is the feature part is also automated. Right? Why is that important? Now, if you take machine learning, we call it when you're selecting features, hand engineering. Hand engineering in the sense you don't take your hand and put it to the data and you engineer it. Hand engineering means you are manually taking this thing, talking with domain experts, so talking with referring to materials, reading books, you are figuring out. But these one thing is, in order to come up with the perfect set of handing features, it's time consuming. Imagine the Apekshati, right? Let's say she wants to talk with thousands of doctors. How many cancer patients will die when she's talking to doctors? She said, no, please, Sudha, are you crazy? Mutta, you tell all the words. And she's considering that because Dr. Ushar also told me that if you this thing, you put the finger, if you can no cancer, you just die because of getting the chemotherapy. So, stand considering to read a lot. Speech analysis part is very hard. And it is not scalable. Not scalable at all. Let's say if you don't know how many features you want, sometimes those features are not good, not needed in another country. Not scalable. And the worst case is this whole model is brittle. It's collapsible. Imagine the Apeksha, this thing. One little feature she missed. How many people die because she missed the one single thing? Her model fails though. Yeta. Nevandi. Not even close. Nevandi. Right? One feature. What? But he's hovering. Come. Come. He'll come. So when I come to my class, I say there are 3 types of students. Army, they always come. Navy, they don't come at all. And you are the Air Force, they come and look and go. They look through the window, and go. Those are the Air Force people. Anyways, it's okay. I think in this class you have Army and Navy only, no Air Forces. They are at home. So, anyways, the thing is brittle. One subtle feature means everything is gone. All lives of hard work. Gone. Broken. That's one problem. Therefore, they had a question. So you understand the relationship. Always asking a question, a solution. Asking a question, solution. Asking a question, solution. Okay. So they had that. How can we use mathematics to understand this? Statistically evaluate all the features in the world and figure out what is the. Imagine, let's say a face detection algorithm. Let's say human detection algorithm. If it's a girl or a boy, there's a Air Force girl. Right? Girl or a boy. How many features now? Take an image. If you take a face recognition one, you have low lines and edges, low level features. Now you have a jaw line, right? It's like a jaw line, no? Master, Master is doing this also. Jaw line. The facial structure, lines and edges. Very, very important. Very important. Structure is defined like that. Now, when you see a girl, you say, Amma, Coca-Cola bottle. That's the Fanta. Yeah, body bottle. You do like this, right? Structure. Nowadays, you see either pencil box or you see what? I mean, guys, not the girls. Like, right, okay. So then you have mid-level features, which defines the eyes and the nose and the stomach. These are mid-level ones. Right? Then you have the high-level ones, where you talk about the picture and stuff like that. Facial structure. So how many features there are? Thousands and thousands of features. We can't say one. Guys, there's a module called Computer Vision and Image Processing in your university course, I think. Yes, you have? Yeah, do that. From that only you will understand. Before doing AI, you have to do that because that is the rule-based mechanism of understanding image-based kind of video analysis through rule-based system experts. Then on those only we learn this. There are tons of features. Hard to figure out sometimes. Very hard. We can't figure out. If you take this space, there are a lot of features. If you take the eyes, distance between the two inner eyes, inner corners of the eyes, unique. It's not the same. You will never find this distance in an eye. Not even your twin. If you take these ratios, unique. If you take this ratio, you take the span of from this year to this year, unique. You will never find a person like that. So these are features that are very important. So, but there are lots of tons of features like that. How can we learn? There should be a mathematical. That's what deep learning offers. You give an image, it will learn these features. You don't know whether it is looking at this thing. Gives all prominence to all the ones. Okay. Cool. So we understand that deep learning goes back to 1950s and 1980s, 1960s, not 1980s, 1960s. But we are talking about deep learning right now, right? Video like 1960s, like your parents, my parents were born in 1974, 1972. Your parents? 1982. So deep learning was there, right? What happened? What happened? Why are we talking just now? Now we are talking about deep learning, right? Now we are talking about deep learning. But in 1950s, this was there. Why are we talking about this thing right now? What's the issue? Information was the big issue. One big issue. Because imagine if you don't have data, what will happen? What is the difference between a person from a University of Moratuwa and a kid from grade 5? What is the difference? What is the difference? There's no difference. So don't tell that. You're going to get humiliated. The whole reputation of the Mora is going to go to Kerala. What's the difference? He's tall, you're short, or you're short, or he's tall. Yeah, tell you. Very good. Knowledge. Knowledge is enhanced through what? Through very good information. So, even though we figured out a mechanism, a mathematical model to understand, which is very intelligent, we don't have information it to become. When we are talking about 1950s, can you remember Windows 95? Those days you had to use 30 floppy disks. Or 1 MB, 2 KB. Now, hey, what you mean? 1 TB at the copper. In your pocket. When you are going down the road, how much? 1 TB, 2 TB, 3 TB. Terabytes of data inside your pocket. This small thing. So they had a problem of saving. This is why Sri Lanka, now we are telling that okay, Sri Lanka is a thriving country, we need to implement deep learning, machine learning. You go to Department of, let's say, Agriculture and ask for the rainfall, or let's say, forget about that, go to the weather department, ask for the rainfall. You have today rainfall, then you go back to 10 years of rainfall missing. Then you have inconsistency. This is why these countries understood that there is an algorithm our scientists has come up with. We need to structure our data. When your data is very structured, in a structured manner, you have enough information to understand something. So they structured. That's why they are very structured. They have 50 years of data. So that's why their tools are very efficient. Decision making is very efficient because they have a lot of data to train. And they have spaces to save. Next thing. Hardware. Today we have GPUs, CPUs, all the PUs we have TPU, IPU, and I just put in there. GPUs, TPUs, and CPUs. You have a lot of hardware acceleration. What you tell when you are buying this laptop, Mommy, I want this. It has this much of cores, this much of this thing. It has NVIDIA cores. Do you use NVIDIA? You are using this thing for Word. No, game. Play game, you buy a Nintendo or something. Why is wasting 300,000 here? 100,000 for your laptop, 80,000 for the Nintendo. Altogether 180,000 rupees finished. Now this thing is 400,000 or 300,000. Then 20,000 same. If my child, I would have done that. You take a second-hand laptop, you use it and buy your Nintendo, you go and play the game. You play whatever you want. Anyways, the GPUs, graphical processing unit. That is why the graphics are, when you try to cut a person, you have all the details and a little bit of blood coming with a very small split. Then it becomes big, it becomes divided. Total. Those days we had Mario. He jumps on the mushroom and it dies. That's all we saw. Now it's very entirely brutal. That's why you guys are not sensitive anymore. My cousin, one of my little cousins, one of my youngest cousin is in grade 4. The boy is playing the PlayStation. When I saw it, I said, what the hell, man, God forsaken idiot. Look at the way you're looking at cutting and chopping people. It's like you're in a butcher shop. And he was like, yeah, I'm killing this bugger. Kill it one time. Why you should kill him? You drag him. Mortal Kombat. You cut it. Then you drag it. Then you toss him up. Don't play these kind of games. Not good for it. Anyways, my cousin doesn't listen to me. He's trying to do Mortal Kombat on me. Since he's only 6 years old, 8 years old, I can manage, I can do the reverse Mortal Kombat on him. But I'm praying, don't do Mortal Kombat when he's at 13 because I can't handle that. So that's all. GPU, hardware, it's very important. Then software. Today, even that linear regression was easy for us. Imagine if you had to write the whole code. We are not writing the mechanism, right? Look at this thing and change, now look at this thing and change. How many code lines you have to write? It is facilitated through the library itself, right? Scikit-learn. It is facilitated. Whatever you have to do is you have to render the function. You have to call the function. Then you just have to put the input. That's all. That's AI. You are just rendering that function and putting the information. That's all. But underneath, there's a big thing going. You can't code it. But now they have facilitated that. Easiness is the convenience. Because of these software, TensorFlow, there's PyTorch, PyCharm, whatever the Py you like, you can use. Right. So you take deep learning in a holistic manner. Deep learning comes to two types. First of all, spatial deep learning methods. What do you mean by spatial? Some say spatial, some say tensor, digital. Whatever the thing is, what do you mean by spatial? Yes?
3D space.
3D. Okay. But you have a NVIDIA, right? You are using it for playing games. Spatial means immersion. You must explain. What's your name? What's your school? Maliyadev. Kurunakara Maliyadev is a profound school, lah. Johnston Fernando is from St. Anne's, right? St. Anthony's. You are playing with the St. Anthony's. Good school. Don't go to St. Anthony's. So any idea about spatial? What about the young lady data science? Spatial. Asli now. Spatial. Partial, whatever is partial. Sparsity. Have you heard these words? Tell me not. No. And what do you mean by sparsity? I don't know. You have heard the word, but I don't know the word. Really? Okay. It's like YCT, GPA, YCT, whatever. Sparsity means what is happening right now. Sparse, spatial, current. You are looking at the current condition and then doing something. Sometimes you have to do like that. You see me, you do something. Current. Is it? So it's like living in the moment. You today eat, drink, you spend the money, tomorrow don't think about. You spend all the money. Having all the fun, going on a yacht. Tomorrow, big. So that is spacious. So there are places where you have to look at the current situation and do something. So deep learning offering that. Two algorithms. What? Number one is artificial neural networks. We are going to learn this. ANNs and 2D convolutional neural networks. 2D convolutional neural network can be used in two different ways, but let's for the sake of the argument for today, we'll think about it using as a spatial issue. Spatial. 2D convolution. Then there are some people who think today and tomorrow of learning from your past experiences, spatial and temporal. With time, you are changing your decisions by looking at the time period. So that is also facilitated through deep learning. Yeah. Spatial and temporal. You have 3D CNNs, recurrent neural networks, long short-term memories, transformers, autoencoders, generative adversarial networks, reinforcement learning. Very big thing. At State we teach all these stuff. But for today, we are going to only teach artificial neural networks, so 2D convolutional neural networks and 3D convolutional. Because of the time we use. You like, you can join our program. Shamelessly market. I hope that I get an increment because of marketing. No, they don't give the increment. No, they. Bonus is coming. Right. So, anyways, so we are going to learn about how ANNs are going to work, how 2D convolutional neural networks are going to work, and I will teach you how 3D convolutional neural networks are going to work. Other parts I'm not going to teach. I will give an awareness of these stuff, but not teach to code. There you go. Is it okay? Are you hurt? Hurt? Illada. So where is it? Okay, let's talk about artificial neural networks. What are we going to try to create now? Artificial means creating. What are we going to create? Neural networks. Where are the neural networks happening? Inside what? Brain, no? So we have to first of all figure out how it is going to work. Yes? Let's take a neuron and see. If you take how does a real neuron work? A neuron looks like this, right? You have the dendrites, cell body, and so on. Medical science. See, computer science, medical science. I told you, I applied in the AI. I am applying AI like Siddhartha. You put it on the tooth and your belly, your head. If you have back pain, you go and wrap it there. If you have a pain inside your belly, you can put it inside the belly and rub. Like simple. Okay. So you have to figure out this thing. How does this neuron work? So you have dendrites. Dendrites are the places where you collect the information. Inside the cell body, the nucleus is the one who is going to process it. Then the axon is the one that is going to output it. So we are going to synthetically create this thing. So basically, dendrites is acting as inputs. So if you take, is it okay if I erase this? Obviously, there's nothing meaningful there. That's meaningless stuff. So if you take the dendrites are the inputs. So you can have inputs coming into your system like this. So you can have as much as inputs you want. There's no limit on that. No limit on it. So the cell body is the one who's going to grab this thing and analyze. So we need something to grab this thing and analyze it, yes? So we have to come up with a thing like that. We call it the perceptron in this thing. The processing part, nucleus part. Then you have the output. Whatever the Y that is coming on. So now we have to figure out, is it too much lazy? Too much lazy. You can go to the back if you want, or I can. You can. Should I reduce it? Can go and. Yeah, you are the only state bubble. You are from up. Yeah. Okay. Good. You said, you feel sad about me. The Bobby is wearing a turtleneck and is jumping and this. You don't have to think about it. It's like we don't think about ourselves. We think about it as That's true. Shamelessly marketing. Shamelessly marketing. Right. So now when we look at this thing, soul structure. And this it will come. When we look at this whole structure, right? Now what should we do? We have to incorporate all these terms. This is basic O-level mathematics. There is O-level mathematics. He is going to sum this thing. First, sum this thing. But sum only itself not going to help. I told you, when you're taking an input, you have to give a prominence. Even when you're looking at something, you give prominence. Let's say you see the love of your life. You have seen movies, right? All the background becomes like blurred and the sparks comes from out from your girl. You feel that, right? Don't you? Sometimes when I'm doing my lectures, girls are like, not because I look pretty and they are classes, because they don't understand what they is going on in the background. Right? So I see some girls like yours, no. Right? So basically, you see what is happening. Whatever the things that are happening, you see it from the background. So when I was playing basketball, I played basketball for my school and for the national team as well. So when we were playing, so we have to guard the person here. So you have watched basketball, right? So no, never watched basketball. I've seen no. You go and watch tomorrow. Not good. When you're playing, you have the opponent. You have to defend your opponent. So this is your man you should guard. But the problem is the other person is bringing the ball. So he will pass for this catch. So you have to look that side also. So when we are defending, we are doing like this. So I can see what is happening here. Until here I can see. Here also I can see. Everyone has that span. The problem is you are not trained for those information. But when we were practicing, we were trained. So my span is like this. I can still have to see what is happening. This guy is coming towards like that. Let's see. So it's because we are trained. You also have that span. The problem is you haven't been trained. Where's that guy? He's gonna come when he dies. He will become Jack from Titanic. Then he is now a little bit like that. Then then you have to go and put him into a sea. Finish the story. I don't know who the rose is, but yeah. Then again, who cares? Right? So, but anyways, so you are not giving a prominence to the information that you are having. You are retrieving it. You are retrieving all these information, but you are not giving prominence. You are giving the priority for the ones that you are seeing in front. What do you get these people? How do you give a prominence through? By giving what? A weightage. Isn't that true? So shall we give some weights to these inputs? Yes. Let's give some weights. This is W1, W2, W3, W8. So if you multiply these two, depending on the prominence, it gets highlighted. Or not highlighted. Let's say if W1 is a very high one, I1 into W1 is a very big number. So that input is highly prominent. Anekolo, can you ask that security guy to come and control the AC thing? Because you know what? This guy will die. Yeah. Sansada නෙමෙයි ඊට පස්සේ සද්ද පෙණිය the පාරේ ගාගෙන වැඩක් නෙයි. Well, Sansada, right? I have a lot of problems when you have a lot of SS coming here and there. What? Yeah, Santa Penny, so be careful to control the AC. They sleep, actually sleep a person. You know, sleep means like cutting the neck, yeah, that's sleep. Anyway, he's from Morocco, so you guy will go and tell Morocco people, these people are freezing us today. And one guy is talking us to death. Freezing also coming 2 times of death. Okay. I'm just making you fun because I can feel the pain. Anyways, so this multiplication will become what? This will be a very high number if this is done. If it is a very low number, even though this is high, this will become low. Correct? So you can give a prominence, reduce the prominence. Introduce a prominence. Yes? Then what can happen? So you multiply this guy with this guy, this guy with this guy, this guy with this guy. Then you summate together. Summation of series. What? I1 into W1 plus I2 into W2 plus ... In into Wn. But you have sigma I is equal to 1 to n I W. Now you get all the information prioritized depending on the weight. Next thing is what? Now input extraction part done. So we have to introduce a run. Now still is this thing taking a decision? No. It's not taking a decision. It should go through some sort of another function to make it a decision. So we are saying that it goes through a non-linear line, non-linear function. I will teach you why it should be a non-linear in the next slide. It goes through a non-linear function. If you multiply positive with positive, what do you get? You get a positive number. Negative with a positive number, you get a. So if you get some summation of series multiplied with a non-linear one, you will get a non-linear decision. incorporating the inputs. Absolutely beautiful. After learning a deep neural networks, I love. After learning AI, is good. The other guy is also some sort of a remote issue. I'm extremely sorry for that. Buddha, if you want, you can go to the back forum. Yeah, you can go to the back class. Yeah. I'm extremely sorry. You are not pleased today, friends. The use for it. Very good. You are from Noel, you know. You don't go to Noel, you don't get that feeling also. So when you multiply this thing with a nonlinear function, you will get a nonlinear. I will teach you. I really love nonlinear functions. Do you like nonlinear functions? Quadratic equations. X to the power 4 to the power. No smaller so chicken. Make a pot baby. That's what he says, right? Orthogonal model. Pot baby. That's what he says. It's a damn idiot. I hate the word. Because these are the people who are making the intelligent people parents. The people who actually very like all these people are very bright. All these brains are the same. It's not going to change. It's the way of training your brain is going to change. So when in your childhood, when you're parroting, you become parrots, not free thinkers. So those are the buggers who are making our generation by generation. These people are going for this. Come. Kollu. Ani make a product. Oh. Ani product the AC එක අඩු කරනවා. වෙදිද්ද? ඕනි. අර කොල්ලට අම්මා වෙලා ගියා අර පිටපස්සට. මම නිකන් නුවරදී වගේ යනන් ඉතින් ඒගොල්ලෝ ඇවිල්ලා තියෙන tropical country. අවනේ ඕස්ට්‍රේලියාව ගියා කැන්බුනා හම්බුනා. Thank you. Now, very good. So, what was I talking about? Yeah. So, don't be parents, be free thinkers. That is something else. So non-linearity, it's very beautiful. These non-linear equations are very beautiful. I will tell you why now. So basically, I taught you this thing. So this is how the algorithm comes. Then the dendrite, the processing part, output is the axon. So it looks like this. Then when you take the equation, it looks like this. So let's say this is equal to G. So basically, this gets multiplied by G. That's all. Okay. This is the nonlinear equation. I will tell you why nonlinear equation is very important. Right? The nonlinear equation is very important. In life, so these nonlinear equations are called the activation function. So this is the one that activates the neuron to make a decision. Okay, so these are called activation functions. Now we have to ask the question, why should these activation functions should become nonlinear functions? I'll show you. This is what actual data looks like. You don't get that dog and cat. You saw the cut clusters perfectly distributed, but in real life you don't get this. You don't. When you are incorporating a lot of inputs, you just now we have a data analytics child, right? Data analytics, right? Yeah. Oh. Data product analyze. Hey, very nice. So basically, when you plot, have you plot data, and you see like this, right? Color So even if you don't, you say, yeah, we did, yeah. Yeah, got caught. Right. So the distribution is uneven. This is the actual nature. It's uneven. So you can't, can you separate this thing with a regression line? Can you? Y equals mx plus c. Can you do that? From y equals mx plus c? Even you change the gradient from top to bottom, can you do? You can't. But non-linear lines, they have the luxury, the freedom to go around these stuff. The non-linear line looks like this. That's a non-linear line. This has the ability to go through these, like slither through these spaces and separate. Absolutely beautiful, right? So you can separate it like this. If you use a y equals mx plus c, prediction is wrong. But when you are using non-linear line, you can make shapes and separate. This is why all these activation functions are non-linear. Absolutely beautiful, right? Amazing. So when you see a quadratic equation, you now pray, wow. When you see a messy guy, that's why girls like messy guys. Boys like messy girls. But who have frequent baths, huh? They should have a bath. If not, stinks. Right, good. So now you understand this thing? You understand? You understand the importance of the non-linearity? Yeah, right, okay. So we call these kind of, so it's, when you take your brain, how many neural connections are there? 6 billion, 3 billion, billions or billions of neural connections, densely connected to each other. So we have to create, this is just only a one, we call it in computer terminologies, we call it a perceptron, not a neuron, perceptron. So we have to densely connect these perceptrons together, then you can get an entire artificial neural, the artificial brain working alongside these perceptrons. Sorry, beautiful. So this is called a dense layer. So dense layer means each and every perceptron is densely connected to each other. You see, this perceptron is densely connected to this guy and this guy. This perceptron connected to this guy, this guy. This perceptron connected to this guy, this guy. Densely connected to each other. If you take this guy, the input is coming from this guy, this guy, this guy. If you take this one, you get 3 inputs from this guy, this guy, this guy. Densely connected. Densely connected. So I'm not going into the lot of functions stuff. So basically, when you're writing, this is only for this is the internal code just for 2 perceptron connections. But when we are writing our programs, now I'm going to show you a program. We're using 128 densely connected layers, 500 densely connected layers. Imagine writing this much of lines, 500 into 2, 1000 lines coming because of. So when you put another one, another 1000, 5000 line code. But TensorFlow, PyCharm, PyTorch, these softwares are allowing us to is convenient. So therefore you can use it. So densely connected layers are there. So this whole code line you can just use it through TensorFlow. This is how much you want. A single line. In TensorFlow, there's a method called Keras. Inside Keras, there's layers. Inside layers, you can take the density. So then you can have 2 densities. That's all. That's how you code. Coding is easy. Neural networks is very easy. Now you go home and tell you know how to write programs. Very easy. It's not hard. But the problem is the way you write it's a little bit hard. How the neurons are working is a little, understanding is a little bit hard. Other than that, it's easy. So if you take a deep neural network, it looks like this here. All these stuff are densely connected to each other. The artificial neural network is densely connected to each other. So if you take the program for this thing, it looks like this. So two densely connected layers are connecting to each other. Right? Cool? Cool. So how does this stuff learns? How do you learn? How did machine learning learn? How did it learn? Through what? Yeah, data. Okay. Patterns. Okay. What about you? No answer. Let's say, how do you learn a lesson? Properly learn a lesson. Through practice, what do you do? Right. What do you mean by practicing? Trial and error. You do it, you make an error, you make it. From what? From? You are learning from what? From? Yeah, I heard the word, what? Very good. Mistakes. You learn from mistakes. So, neural network should also learn from mistakes. That's what our thing is. That is how we train our neural networks. We are training them to. That's what supervised learning means. Yeah? We are telling them this is the what you should predict. Okay, put the image. Look if you are predicting the same thing. And look at the error and you are fixing. Absolutely beautiful. Now, if you take this thing, so the loss is the most important part. So basically, what we are saying, the capital L means the loss. They are comparing the predicted one and the validating one. For that image, what was the predicted one? What was the actual prediction? You compare these things and you retrain. So what can you change during training? Now when you do this thing, when you're writing your program, inputs are fixed. You can't change the input now. During training, you can't do that. Activation function, when you say this is the function you want, that is also fixed. What is the only thing that we can change? We can't change the input. We can't change this G. What is the remaining variable that we can change? Okay, bias is also not going to change. What is the remaining? If you look at this equation, what is the remaining one that you can change? You can't change I. You can't change G. What is the weights? These weights can be changed during. That is what happens. So let's say at the initial stage, this one got a higher weightage, right? And you're making a wrong prediction. You change it. And you run again. And rerun again. You're going during each and every iteration of training, you're changing the weights of the neural net. And the weights are changed according to another function. You look at the loss. By looking at the loss, there's another optimizing part. Optimization. There's this Adams optimizer, optimizing part. Then the amount of weight that you should give is predicted through the Adams optimizer by looking at the loss. By looking at the comparing the loss, the weight of the loss, the impact of the loss, you are changing the weights. Statistical. Changing the weights. Okay. So that is how it is happening. So if it is a binary class, you have to use this function called binary cross entropy. You guys have heard about entropy, right? Where do you heard this entropy part? Very good. Chemistry. What do you mean by entropy? You guys don't know. Entropy here ne Dushyant sir ke class mein mark karega. What do you mean by entropy? Why do we need entropy? Is entropy only for chemistry? You thought so. I thought so. Entropy na chemistry. Physics sir. This one. Amit Pushar. Physics na Amit Pushar. Amit Pushar na physics. Yes. Entropy means subtle changes with a function that can take very small changes. Now, chemistry is involved with a lot of chemical bonds. Subatomic particles are going to get connected together. Can you see the when you are drinking this thing? This is what H2O. Can you see the H2O here? How can you say that there is H2O? Then you are putting something. Chemistry. You are putting something. The changes, the heat dissipations are very small stuff. You can't see it from your eyes. You can't. So you use the entropy mechanics, entropy functions. So why are we using entropy functions here? To make sure that subtle losses, even very small losses, are detected. It's like magnifying, like log figure. You know why you are using logs? These are profound mathematicians, right? In Sri Lanka. You don't know why you are using log? No. Yeah, enthusiastic. You don't know why logs? What do people tell me why are you using logs? Himachal, log. Mariade, log. You are looking at the logbook. Logbook in the sense of the logbook that you write. You look at the log and you write something, right? Magnification. Simplification. Really? You are magnifying. When you have 10 to the power minus 2, you put what? Log? You write, the log can write it, right? Because you can't see that subtle one, small one. But you can, when you put it to the log scale, you can magnify it. Very subtle things. That's why we are using log here. See? Subtle stuff is going to get detected. Very beautiful. Very small numbers, 0.00000001. And write it. Can change the subtle changes. But you can convert it into log, right? Yeah, simplification in that sense. Yes. But actually the thing is, you are doing is you are magnifying and seeing so that you can have log also another point decimals. Absolutely beautiful. Absolutely beautiful. This is very beautiful. It's like a magnifying glass. Log is used for that. Oh, cool. So entropy functions helps you see these subtle variations. So that's why for binary, it's a one function. I'm not going deep in maths because no need, no. So then you have this thing called for multi-class, you have mean square error. And also instead of this thing, you can use multi-class. Categorical cross entropy function. There are two functions you can. But most of the time I use the mean square error function because it helps to find it faster, but it's not sensitive as categorical cross entropy because mean square error is like you take the mean of the errors and take square root. So mean square error functions is just a simplification of this thing. Whatever said or done, this is going to use the loss and figure it out. So we are using this loss to determine what are the weights we have to prove. The weight distribution. After training everything, you will get the weight properly distributed. The weight is estimated through the optimizing. I will show you what will happen if the optimizing function is not figured. So I want to show you this one. So this is a plot of distributions of weights for my neuron. For my lifetime, I have written more than 200 neural networks. Only one time I achieved this globally. It's very highly unlikely to reach it. You always settle in these local minimums. Why? Because of this problem in this gradient descent function. That function itself is very very, very, what do you call it? Very spooky. He's playing around with us. After, so that's when you're writing, I didn't put that in my code that you are sharing it. There's API called Comet API. So you can hook up the Comet API. Through the Comet API, you can get this plot. When it rains, you can check where the actual loss is going, there's the local minimums that were generated, what is the global minimum, what is the minimum you achieved, and what is the deviation of the global minimum to the local minimum that you settled. Because let's assume that in a attempt you started here. If you take this direction, you'll go here and settle here. It's the local minimum. By depending on the slope, you are thinking, okay, this is the minimum that you can achieve. But if you take this path, you can go here. It's very tricky. So out of more than 200 codes, only one time I achieved, I took a snapshot and keep it with me so that I can show it to people. So that is that way. So basically now you understand even ChatGPT can't have the actual global loss. So which means whatever the predictions that are making from ChatGPT is not 100% correct. No AI model can replace you. That you should understand. But you should be able to comprehend what the AI, how the AI algorithm is working. That's what you should do. You should learn it and understand that this is too big then. Then you don't rely on. Understood? Good. So if you take this thing, this is the optimizers. So in optimizing function, this meta, the learning rate plays a major role. You can see that the optimizer is taking the weights and comparing the losses and taking with time how the weights are going to change. It's going to figure it out. So this learning rate is automatically fixed by these optimizer functions. But you have to understand that higher the learning rate, the lower the learning rate, what will happen? So when you are choosing it, so optimizers, what it does is it changes dynamically, adaptively, it is going to change this learning rate and figure out the losses. Right? So in here, trial and error, adaptive learning rates are there. So I will show this video. So let's say that you get an initial guess. Okay. So what will happen when you have a small learning rate? See, this is the actual local global mean. But when your learning rate is so small, you don't achieve. When you have a large learning rate, it overshoots. It overshoots. It doesn't reach that goal. It's way more. See, goes up. When you have a stable learning rate, see. So you understand how does the learning rate is going to affect your program. Very important. But the burden of changing the learning rate is not on your shoulders because anyways Adam, MIT, the guy called Adam from MIT has developed a program so that it is giving a suitable, stable learning rate. You just have to use it also. But you have to understand the importance of this thing. Importance of coming to the global loss, to the global minimum. That's very important. That is the most optimized answer. It is the lowest error that you can, lowest loss. So let's assume that you settle it here. What will happen? You are taking the weights, okay? Whatever the 3D, you have your weights for this thing. But you have a tendency to you had a chance to go to an even more lower loss for a weight configuration, but you didn't achieve it. It's a problem. So you should understand that it is very important. Okay, the same video. So you have a couple of learning optimization functions, Adam optimization, ADA data. I have used this STD ADA data, but the logo too I haven't used it. You use it and see because Adam is the one that I use most frequently because it's really good. The learning rate is also really good. RMS Prof and ADA card, I haven't used it, so I can't say. So it when you're no, that is all about learning. That is all about losses and everything. Then you're fitting the model. That is also very important thing. Now, when you're running your neural network, it will say 96%, 98%, but you have to make sure that if it is fitting properly. If it is underfitting, obviously the accuracy also bad. But if it is overfitting, it will give a 98%, 100% accuracy. What do you mean by overfitting? It gets biased towards the class. Even a subtle change, you think, no, it's this one. It's a radical mindset. Inside, you're creating a radical mindset inside the neural network. No matter what you do, he says a fault. Even if you give free Wi-Fi, that is a fault. No, I'm not supporting the bucket. But what I'm saying is just to make you understand. See, that is a radical mindset. You have to wait out what is good, what is bad. People have done bad stuff. Some person is doing a bad guy doing a good thing, it's also a good thing. Just because he's a bad guy, it doesn't mean that it's not a good thing. As an example, the guy who sells drugs can go and build a temple. We don't go to that temple to worship. That's a signal. You can go. It's a good deed they did. The way he's earning is bad. He will get the punishment. Overfitting is also a thing like that. When you get overfitted, that is the problem also. So misclassifications are happening. No matter what happens, now let's say if you have a cat and a dog and the algorithm is biased towards overfitted to the dog class, even if you show 1,000 cats, it will say dog. No, the ear looks like dog, it is a dog. The beak, the mouth looks like a dog, it is a dog. Dog. No matter what you do, it's a dog. So one way of fixing this thing is like early stopping. There's a mechanism called early stopping, and there are dropouts. These are the two mechanisms that you can use. So there's a small program, you can go through it. That's not going. So basically, this is a neural network that I wrote for head movement classification. So basically, you have to use these Keras libraries. So inside the Keras libraries, only you have these functionalities. Anyways, let's move on to the model creation part because we don't have that much of time. So, right. So from Keras, so all these models are sequential models. Neural networks are sequential models. They are not parallel models. First of all, when you have a layer, you have to run that. Then the second layer, then the third layer, then only the final layer you can execute. It is in a sequence manner. So that's why when you are taking, there's a thing that you have to import sequential. Then now since this is an ANN, artificial neural network, so you have to take the dense layers out of. So inside the layers, you have the dense and the dropout for overfitting problem. Okay. Right. Other ones are batch normalization, data pre-processing stuff. Right. I will go to the neural network itself. So you can see that first of all, you have to tell that this is a variable name. Okay. You can give any variable name you want. Let's say model A. You can put it as ANN, C, whatever the name of you want. Then it all whatever the name that you want to put, you can put. It is not a mandatory to put model. Now people think that okay, you have to put model. No. You can put a variable name for your model and just say that it is sequential. Then first of all, add dense layers. One dense layer. Then this is a batch normalization in order to make sure that these weights are normalized. I'm not going to in that depth of stuff because when you normalize, it's really good. I don't want to go that much in there. So then you have another dense layer. So you see activation function, rectifier linear link. This is a rectifier linear link is a non-linear function to activate that. Right? Activate. To have that, you have that. Then 5 classes. Then when you are compiling it, when you're compiling the model, you have to tell what is the loss function. Since it's a multi-class, I have 5 classes. 5 classes in this thing. So therefore it is a multi-class situation. So I can't use the binary constraint entropy function. I'm using the categorical constraint. Then I'm using the Adams optimize. So this is the learning rate here. You can change it as much as you want. Then the make accuracy. Then you have then you are starting to train model fit. You have to tell what are the training data for inputs, what is the output training data, number of iterations, verbose don't fit. So in order to validate, what are the testing X data, what are the testing Y, the relevant Y testing data. So when you do these things, this. So when you're running each and every iteration from this iteration to this iteration, you can see that the accuracy is getting higher, right? 34% to 54%. So in order to do that, I have changed the program has changed the weights. Next time it has become 60, 63. Likewise, it is getting increased each and every time. So when you after a while it was 70%, 73. So then you have to have this plot. This plot explains about the overfitting part. So you have to check whether the actual loss and the validation loss are converging. I mean, in this case, it's not converging because after here it starts to overfit a little bit. So when these two are converging, we are saying it's a stable fit. I told you ideal fit. If this thing exceeds, it starts to become overfitting because your validation loss is overcoming the actual loss. So that is a problem. So that is the time where the overfitting is started. This is how you can detect if there's an overfitting or not. I'm not going into the mathematics because the big mathematical thing. I will take since we don't have time. I just want you to understand that when you're validating just check whether how to detect if this thing is overfitting or not. Because you have to make sure it is ideal fit. Now all my students who's doing research with me, I make sure that these things are getting converged from. All these models are even the accuracy is not that high. It has the ability to detect subtle changes and classify it properly. Very rarely only it gets misclassified. It's not about the accuracy all the time. It's about achieving the ideal fit. So we have to make sure that it is converged. So you have to change the weights, yada yada. You can change the number of dropout players. You can do early stopping. Early stopping is not that good because sometimes when you early stop, sometimes let's say in here it starts to overfit. So it will stop here. It's converged, but look at the loss. Loss is high. You are not achieving the best accuracy. So sometimes we use mix of dropout players, things like that. Okay. So that's that. Now let's talk about this 2D convolution neural network. Okay. So the thing is, 2D convolution neural networks allows us to see things. Now only we are starting to, neural networks are allowed for data analytics part, right? Sensors you can do. But in order to give vision, you have to understand what is the importance of vision, like camera processing, video processing stuff. This is how they start. Using 2D. My eyes are my favorite part of not for how they look, but for what they see. So if you don't see anything, what will happen? Lot of information inside your head is not good. How can you feel the difference between black and white? How can you tell that this girl is black and this girl is white? It's all because of what? Because of our eyes. How much of context are we talking about? We can see subtle changes. If your eyes are closed, can you walk? Even you can you adapt to these environments? No, right? So imagine if we can give that sight ability of seeing things to computers, you can do one. One such a thing is convolution neural network. So if the importance of computer vision. See, have you seen this? Look at that. Dancing robots. You see these people getting collided? Hit each other? No. Why? They can see each other. How can they see their movements? Because they can see each other. You see the importance of computer vision. You see the importance of 2D convolution neural networks. This is wonderful, guys. Wonderful. We are giving sight for these things. And then we are making decisions. Not only that, not only robotics, but also mobile computing, selfies. How many times we get fooled because of the Facebook photo? I fell for 4 times. You see the girl like Amma Tasiri, Rani Mukherjee. Then only it is like not Mukherjee, you put the poo. It's like a matala palm face. When you take the photo, you can sandpaper out everything, right? Then got more mother. It's because of what? Again, 2D convolution. Your phones are running these stuff. This is because of computer and they can detect your face. Now, my face anyways looks good, no problem. So you can make it worse a little. So see, what can computer vision do? Absolutely amazing. Biomedical engineering. Nowadays, breast cancer. This is a breast. Even if you can't see it, it's a breast. So, right. So, when you have a lump, when you have a lump, when you not only the breast but also the chest, if you feel a lump, you can go and check whether that lump is cancer or cancerous. But if you take an image before that lump is happening, you can see that little small clot starting there. You feel it when the clot is big. Then whatever the things that should happen has happened, spread all over the place. Even for a person to see, it's very hard. But when you convert it into numbers, you can see that lump, small lump. Computers can see that you can't feel. Absolutely amazing. Again, because of what? Computer vision. Autonomous driving because of what? Computer vision. Accessibility. You can create, you can like you have phones that can understand the context and tell. Because of what? Convolution. Because of computer vision. This is absolutely beautiful. So we talked about computer vision in mobiles. This is an autonomous car. This is at MIT. This is a Toyota Aqua. See how it is driving, how fast it drives. See the steering. Absolutely beautiful. Yes, absolutely beautiful. So we talked about this in breast cancer, COVID-19. These subtle changes in X-rays can we see? This is a blind person jogging. Imagine a blind person jogging. Because of what? Computer vision. 2D CNN, 3D CNN have facilitated new eyes for you guys. So you have to just to hook up into your, I think this was done in Australia. So you hook it up in your this in bed. When you're running, it guides you. Says if you're going towards the line or going out of the line, are you on this thing? Is it the vehicle coming? Are there potholes? You can run with this thing in Sri Lanka because you have a lot of potholes. So the thing is not working properly because it's always vibrating, so it can tear off. And sometimes crocodiles. You run on these tracks, always crocodiles. I don't know why. They put poison crocodile. One day I was also going, and I said I didn't see this sign of it. It was on the road there. It was not on top of this. I told, is there crocodile? Oh yes, sir. So we not directly meant to be tracking what is there. I said I ran the other way around. I said I will never run on this track. Very crazy. Nothing in Sri Lanka, but in other countries you can use it. You're blind. So nowadays becoming blind is also not a problem. The thing is, how does computer sees it? Basically, it takes a snapshot. Now this is a good-looking guy in my class. So I take the good-looking guy first and put up here and mock him. I remove your ones. I couldn't find your face. Kind of a good-looking guy. Yeah, so I good-looking, kind of. Yeah, but I haven't only done not yet. Hey, after that, we'll fight. Not done. And he gets the end pass. Yeah. A snapshot. You take a snapshot. This is what you see. What you see. But in a computer manner, it takes this conversion. It converts into a 2D matrix size. This is the one that the computers. Whatever the light that is reflecting into the lens, convert this into 3 types of numbers. Red. What is the red colors? What are the red colors? Green colors and blue colors. Right? So in 2D convolution, 2D means what? 2D means what? 2-dimensional arrays. You are going to analyze these 2-dimensional arrays and tell what is happening. Absolutely beautiful. Now, if you take, how do you take this stuff out? If you take, you know this guy? Who is this guy? Huh? Good. In this class, there are 3 people who knows this bugger. In my classes, there are no people who know this guy. It's Abraham Lincoln. So Abraham Lincoln's, So Abraham Lincoln is, when you take the pixels of this Abraham Lincoln, all the information about Abraham Lincoln is here. The color, the shape of this thing, the eyes, everything is inside these numbers. You can't see it. So you need a mathematical operation to extract. The mathematical operation that we use here is convolution. I'm not going to teach you convolution operation because it's small. So that is the extraction part. Right? So if you take features, if you take the low level features, you can have the jaw lines, eyes and the nose, and high level features, facial structure. So these stuff, if it was manual, if you are manually extracting, what are the problems you can have? One thing, if you're variation of problem. Someone can take the imaging like this, like that, like this, like that. Variation is it. This is why the point is why deep neural networks is important. If you're using machine learning, you can use machine learning for this thing, for image classification. But the problem is you have to, in machine learning, it's hand engineered features. Yeah. So what is the problems in hand engineering? Where you point variations, then illumination conditions, scale problems, deformations. You have a cat like this. Background color, occlusions, these are some problems that we have in computers. When we are used, that's why we need a mathematical technique to extract this, so that we don't face these problems. So the way of taking this thing is very simple. The problem is we can't fit a 2D array to this setup, right? Can you say this thing? Why? If you take this thing, the input is a one single array transposed, right? Can we fit it? Can we fit an image to this? Can we do that? Can we or can't? You take a 2D array, and if you try to fit this thing, will it work? No. You have to convert it into a format so that you can fix it, right? That is where convolutional neural networks are going to help. So you cannot do it directly. So you have to use this format. Basically, you have to use convolutional layers to extract information, extract it. Then you can hook it up to a basic connector. So we'll go to the code and try to understand this. So basically, this is a object recognition one. Okay. So you have aeroplanes and horses and trucks and everything. Right. So we'll try to understand this thing. So you get an image. That's the marker. This thing is not showing. Okay, this is the one. Okay. So basically what I'm trying to do is, let's try to understand the code layer by layer. Number one, right? You have an image, which is a 2D image. Let's say it's Otara, Utara, or whatever the person. Utara. Sorry, you don't look like this, you are very pretty. But the problem is my artistic skills are like Michelangelo. That's it. Yeah. So when I want to extract this thing, right? I have to use something called a kernel. So kernels are like, if you want to extract diagonal lines, you can say that okay, this is diagonal. This is diagonal line, right? So you keep it on top of it, you do a operation, you extract the diagonal lines. Likewise, you have different kernels, right? Right? So that what is the convolution layer does? You are using 32 kernels 3 by 3, extracting features, right? Extracting the features, right? 32 convolution operations with different kernels. Yes, 32 different kernels are going to use the convolution part. So it's going to extract whatever the information that is inside this image and give another 2D matrix, something like this, right? Then I'm using this thing called max pooling. What do you mean by max pooling? What is this max pooling? So let's say whatever the information you get, it goes here, right? Let's say, let's put numbers 9, 10, 11, 33, 4, 5, 6. Eight, 4, 3, 2, 1, 10, 14, 12, 13. Say that. We'll say that whatever the information that was there, now reduce, extracted. Now there is a kernel. There's another 2D matrix. From this 2D matrix, we are only extracting the highest numbers for the kernel. What is the kernel size? It's a 2 by 2 kernel. So you take 2 by 2 and you extract the highest number. What is the highest number? What is the highest number? If you consider these four, 30, 33. Then you stride it like this. Then you compare these four. What is the highest number? 11. Then you stride it again. You take this thing. What is the highest number? 11. Then you go down a bit. You take this thing. What is the highest number? 33. Then you go back again. You compare this thing. The highest number is 8. Likewise, you extract the highest features out of it and create another. Then you are that way again do 2D convolution. Again you are extracting features out of this. Again you are taking the maximum ones out of that. Again you are putting it to that. Again taking the maximum features. Now this depends on trial and error. This is where when your this thing is not getting converged, you can introduce more layers or take off some layers. Let's say if it is overfitting, you can take off, which means that you are extracting more unnecessary information. So you can take off some layers out. You can remember Mayer, right? The convergence, if that is overfitting, you can take off. Let's say, okay, this is getting overfitted, so I will take off this layer and check what will happen. This is getting cut. Is it getting cut? Still no. Then you lose another layer and say, because when you are extracting more features only, you get overfitted to one specific class, right? Then I can change this. There is max pooling. There's a thing called mean pooling. You can average it and take the median. So you can use different techniques to introduce overfit. So these are the architectural changes that we can do by looking at the overfitting. Convergence. By looking at the convergence, we can change the architecture. Right? So this entire up to here, it's feature extraction. You should understand. After that part only decision making is happening. See? Feature extraction, then the decision making, then stays there. See? But I told you, still it gives a 2D kind of a matrix. Now this is just an arbitrary matrix. Right? The 2D matrix is going to remain. Still you can't fit it to the densely connected layer. Then what are you going to do? You are going to use a function called flatten, which will convert this whole, let's say some sort of a, let's say a 3 by 3. Now after this thing you get a 3 by 3. You can convert, when you are using this flatten option, all these things comes under one single array. All this information is flattened into a one single array with 9 elements. Because you have 9 elements, it's set to a one single array. Then you can connect your neural. That is why the flattening is important thing all the time. You can't use it. You can't directly connect this thing. It will give you an error. It will give you an error called shape is not fitting. Shape, we shape it and fit. Then you have to erase your flattening that. The rest of the part is the neural network part. Then only the decision making part is happy. Now you have extracted all the features that you want and connected to the densely connected. Then you can make the decision. Oh, where's the cursor? So yeah, this is another way of looking at the accuracy wise, or the other one is the loss wise. So still this is overfitting. I didn't change it a little bit. Just wanted to give you an understanding. Okay. So that is 2D convolution. But in this case, you are looking at frame by frame, one frame at a time, which means spatial. See, looking at now frame and taking a decision. Second frame, taking a decision. Third frame. But a video is what? A full set of frames working together. When you do it like this, you see a cartoon. Now we have to check. How can we do that? Extract information like that. That is where 3D convolutional neural network comes in. So these are called sequence modeling. Now, if I show you this thing, what do you feel? Is this guy standing in one leg? Yes? Like this? By looking at this, you can come up with a lot of answers. One can say he is standing. Someone can say he's walk. But actual thing is, if you take the other frames with it's running. So you have to look how the foot was moving to figure out whether he is running, walking, speed walking, whatever. This is what we call sequential modeling. So the involvement of temporal features is very important. If you take an audio signal, you can break it into parts and understand. If you take this thing, text, you can take as letters, words, and understand the meaning of what you are doing. Therefore, sequential modeling is very important. Now you understand the importance of involving the temporal field. It gives you a more context of your decision. More wise decisions you can take. Your algorithms can take a lot of decisions. Yeah, very beautiful. So if you take sequential modeling, so you can use it for signal analysis. Sorry, signal analysis. Imagine how can you, now we had Ditva, right? Ditva, even we got the prediction we didn't do anything. There is something separate story. That is how our engineers are in Sri Lanka. But in other part of the world, they can detect the landslides prior to the event, right? Okay, in this region it will happen. Because of what? Sequence one. You can put it into signals and check if it is going to predict, if it's going to come, you're predicting. Weather predictions, stock market predictions, video analysis, everywhere you can. This sequence modeling is very important. Everywhere you can use this thing shamelessly. I told you it's like sitare. You can rub it on your tongue, put it inside your tooth, and do whatever you want. Absolutely beautiful. Yes. So you will learn it through. So deep sequential modeling. So we learned about this spatial model one time, but deep sequential models are there are three types. One to many model. It's like you are you're predicting an emoji by looking at the context of what you are saying. One to many. So many to one. So you are taking an entire paragraph, reading and giving an expression. Entire paragraph you're reading, and it this is smiley emoji. Then you have many to one model. So basically, you are giving just an image, but the model is predicting a baseball player throws a ball. Understanding the context, figuring out he's going to put. You are just giving one image. It's predicting you the thing. Then there are many to many models as well. Translators. So if you're using Google Translator, when you put in Sinhala, give you English, right? The same term. This is facilitated because of what? Deep sequential modeling. Very absolutely beautiful. So when you are doing designing these deep sequential models, there are some criteria. Yeah, what is the perfect size for a woman in inches? What is the perfect size? Size matters, right? I mean, like deep size. What are you thinking about? Naughty guy, no? But I was thinking about the equations. I mean, what is the perfect size? That is important because we have to figure out what is the length we are going to predict. Okay, let's say if an event is occurring within 2 days and we are predicting only 1 day, next day we will die. No point. Size matters. Then the dependencies. You know this thing called the pyramid of capitalism. You think that the superiors are doing really good. This is what Gotabaya was thinking. And what happened? The working class people, if you take this thing out, everything collapsed. What happened? Gotabaya was running all over the country. We were searching. He was hiding. one small thing, the dependencies, you have to figure out what is the link, that is also matter. That matters a lot. The other one, organizing. If you are not well organized, again a problem. The last but not the least, share parameters across the sequence. No relationship is all sunshine, but two can share one umbrella and survive a storm together. See, philosophy. So see, when you are doing neural networks, you become a lover, romance, everything. You have to be like that. You have to share your stuff. You share parameters sometimes. If not, you can't build deep sequence models. Understood? These criteria are very important. Very important. So 3D convolutional neural networks are entirely based on videos. Then you have recurrent neural networks for textual stuff. Long short-term memory, text plus forecasting. Then you have transformer neural networks. And yeah, so these are very important sequences. So 3D convolutional neural network, what is it? It analyzes videos, frame all the frames. Now this is frame by frame, right? Uttara. So Uttara is smiling. Uttara was like this. Then Uttara changed it to something like this. Then when I'm looking at her, she do like this. When I'm looking away, she is doing like sorry. Looking away, Uttara is showing a tongue. So this is an entire set of frames, right? So you have to come up with a mechanism where you can extract not only this frame but also in the depth what was happening. That is called 3D convolution. So basically, I have a small clip that shows here how the convolution is happening. So you see, these are 3 frames. You're getting the context of all the 3 frames. When you're making a decision, see? So you understand what was happening. For all the 3 frames, she was changing her emotion. Absolutely wonderful, right? This is how the neural network is working. When it's learning features. Wonderful. Wonderful. So when you change it, it's a new information. It was going from top to bottom, now bottom to top. See, another new set of features are going to come. So left to right, right to left. You can do everything is coming, all the information. Absolutely beautiful, huh? Absolutely beautiful. So the pooling is also the same structure. So we talked about it. We have to use a flattening layer. If not, we can't use. So all these flattened data is sent to the densely connected layer. Then only the decision is made. So there are application of video 3D CNNs are like video analysis, medical stuff, and 3D spaces and everything. So there's a small example. It's like same as the 2D convolution. You have to use max pooling. So 2D changes, just the two part becomes 3 and the size becomes, then that's all. It's the same thing. So you have to extract it, then use max pooling. Max pool again if you are extracting, you can max pool it, then you have to flatten it and give it to the dense connector. That's all. I will send you because you don't have enough time to go through everything. Challenges are like 3D CNNs are significantly computationally complex. It requires a lot of GPUs. Nowadays don't. I'm going to show you why. So it needs large data sets. Now we'll talk about future of AI. Which is the, don't worry, this is the last slide. Everyone is happy. Now we talked about different aspects of AI, different theories of AI. What is the future of AI? So if you take a look, global context plus the local context, one thing very trending these days is multi-model AI solution. What do you mean by multi-model? So in University of Monaco, you see AI things, right? You put YOLO, but we don't use YOLO in Sweden. We prohibit it. We are using our own architecture. I will tell you why. Because of the second, right? YOLO, emotion classification, that's all, right? Emotion classification. Yes, only color recognition. Only color recognition. Multi-model means you're using two types of AI algorithms and merging and giving a decision. He built a robot. I'll show you now. This is called EDA. It recognizes the emotions and intelligently changing one of my research years. This is annoying. Right. Now the emotion part is done. Now the robot is using. It's going to analyze your voice.
After me, I like playing catch.
I like playing catch. I like playing catch.
Copy the robot. So there are two models running. One is for emotion. The second one is for speech. Synthesis.
I go to school every day.
So what is the purpose of this robot? The purpose of this robot is to play with the child and figure out whether the child is having abnormality. Emotionally plus verbally.
Puppy is playing in the garden.
So after everything,
the puppy is playing
after
in
all
the
this
garden.
test, it's going to use this thing and give a decision saying that emotionally plus verbally, this child is having how much of her ADHD?
Hey, I can run, jump, and play.
I can run, jump, and play.
You see, this is the future. This is called multi-modal AI.
Can you tell me what is your favorite food?
My favorite food is pasta.
So there is a both tasty. What tasty?
Can you count to 5?
I don't have the only coming from.
1, 2, 3, 4.
So there are a couple of tests that it does. So now it's going to over. Now it's going to give you a score. See, typical. See, why? So the person who was doing the test was typical, a typical person. So we tested it on LRX. We were able to predict it very quick. This is one future of AI. With this work. So we were asked us to, we were in a small TV thing where we discussed this project. So the other one is cost-effective AI solutions. So basically, this is a 2D convolutional neural, 2D convolutional neural network, correct? Right. Okay. So what we did was, the initial model was 78 kilobytes. We were able to drop it to 8 kilo. 8 times lower, small models, by achieving the same accuracy. Understood? See, it was 97% when it was 78 kilobytes. 8 kilobytes, only 1% of detection. We are running this on boards which has a RAM of 512 MB. No Jetson Nanos anymore. No Raspberry Pis anymore. Raspberry Pi 5, 2B, 3B, we are not using at all. Cost effective, guys. The whole thing, we developed an education system, a small box of a small computer, where it looks at the emotions, again a multi-module concept, but using cost-effective AI solution merged together. So it has language, emotions, and everything. And it is understanding your emotions and choosing what is the problem. What sort of questions should I do with this person? Is this person is comfortable on doing this thing? Amazing. Again, a fourth year. Amazing. You are doing amazing. So you can do this as well. I'm showing this because you should do this. Another area is AI as a tool of science. This is what I'm doing with Oxford University of Oxford. So I'm developing an AI-based tool for them to see some. So they have come up with an intervention called the sleep. Like through sleep, we are trying to cure Parkinson's. So there's a very big medical backstory. Just I will tell you. Through sleep, we are going to improve rather than giving dopamine. Dopamine is like there's levodopa. So you can just inject dopamine. So your muscle movements are becoming smoother. So because when you have Parkinson's, you have tremors, not like this. You're doing like this and going like that. So when you put dopamine, this gets relaxed. So excessive dopamine goes for addiction. We also have dopamine. No. So basically, they had a problem. Oxford, even though the benefit of sleep is very small, they couldn't see through their eyes. The way of diagnosing is there's a thing called MDS-UPDRS, Universal Parkinson Disease Scaling Rate. So they have to look and they have to mark it. You can't see subtle improvement. I developed them a program, AI tool, using these AI algorithms to measure the sleep rate. So AI as a tool of science, a new point of looking at the problem, new way of looking. AI using as a science, new way of looking. That is a new way of in the industry you can use. Finally, but not the least. So yeah, so this was the results we got. So we see a clear difference. See? Improve. The motor movements are getting improved. So final one is unsupervised learning and reinforcement learning. So this is also a thing that I developed. So new insights into the not traditional supervised learning mechanics. Right, guys. Okay, with all these stuff, now we can finally conclude saying that thank you for being a good audience and not doing. Boo! No. So thank you so much. Thank you for. How was the session? Huh? Learn something.
Small Q&A session.
Yes, yes, yes. Yeah. So, do you have any questions?
So, we have put into the chat QR Padlet. So you can drop any questions you have to the Padlet there. So it's in the WhatsApp chat. You can begin with the Q&A.
So now there's a Q&A session. No questions. You can ask any question. You have a question? Yes. Any question? So when I do exercise, it's like this and no problem. In your university, they don't sit on this seat. They don't. They wear the tie and everything. Very professional, no? I'm very unprofessional about it. But I do contribute a lot. So any questions? Any questions? You can ask questions. You will never see me again. Yeah. Oh my gosh, there are a lot of questions. Who's typing this? First question.
First question is there any that's the future for the loss function
Is there what?
Is there any methods to choose the perfect loss function and optimize?
So yeah, so perfect optimizers and the loss function. Again, I told you, like the method is there you can use this Comet API. It's easy. You just have to make an account to Comet, and they will give you an API key. You have to link your just you have to render the thing using an AJAX call, and then during the training process in the Comet API, they show the parameters. They show how the thing is learning. Then by looking at the way it learns, by looking whether it is reaching the, you can change the parameters. You can, let's say you are using, and this time you are using categorical cross entropy function, right? Then you can see how it is going to work. If it is not achieving the global minimum, you can change it. Root mean square. Look again. If it is not going to happen, use another one. Then you change the optimizer function from Adams to Ada Gardo, Ada Delta, whatever the thing, you have to use Comet API. Okay. That is the way I use. That is the way universal people use. But sometimes it's very hard to figure out the parameters. Some parameters are there. Like, just look at the plot. What I showed you, the 3D plot which is goes like has global minimum and local minimum, that is. Yeah.
So what projects should I develop to understand AI as a group?
What projects? So I'll share some forwards. Develop some small 2D convolution. Not 3D. 3D is a little bit hard because one thing is like 3D is sometimes very hard to figure out when it goes in depth to figure out whether the training process is smooth or not. For that you need a lot of math because you have to understand all the what you're changing. Converging parts are a little bit hard. But start with the 2D convolution. It's easy. You can take the MNIST dataset. MNIST dataset has there's MNIST dataset. There's a dataset called CIFAR and closed and everything. So you can use those datasets and create more. Those programs are only 5 or 10 lines. Yeah. So start that. Then after a while, so now we are using ensemble modeling like we now at SLWIT we are using ensemble modeling technique. So we have 3 types of convolutional models: merge, extracting, then merging them together. These are called ensemble models. Now, you can search and do, but the problem is you won't understand because you guys are first year and second. Do a small 2D condition, that's enough. Any other?
How does the agents work and work with each other in agent people?
Oh, yeah, you mean like reinforcement. So there's a now we didn't cover that part. Have you heard about this thing called generative adversarial GAN? No. You guys have used this style GANs things, right? No? Okay, let's assume that now one guy is there from cyber security, right? There are have you heard about a thing called intrusion prevention and intrusion detection system? IPS, IDS. Ah, good. Now these IPS, IDS are nowadays smart IPS, IDS. There's a technique called honeypotting. Have you used honeypot? Ah. You are doing cybersecurity or I am doing cybersecurity? I am doing cybersecurity. So there's a technique called honeypotting, where you synthetically create a place where you show that the person who's the third party person who's getting attacked, you give a sense saying that okay, this is really secure data is there. Then all the attackers are coming there. Then you are creating the agent, AI agent. Yeah. Right? Then you are understanding the type of the attack. And then this agent is looking at entirely looking at it. So GANs are working like so. Generative adversarial networks has two parts. So you have the generator, the differentiator. Right? Right. So the differentiator is another AI one. So we didn't look at that. So there's this value learning, policy learning, big thing. Right? So what you do is this agent is looking at that honeypot. Looking at how the attack is coming. Then he's changing the policies of the. So if it is policy based learning, look, change the policy of the discriminate. That's the way they are said. There are two methods: value learning and policy learning. This smart honeypotting, we use most of them policies because these are policies. We are having firewall policies and everything, protocols and everything. We are changing those things. That is so basically the communication part is happening like that. By one agent is looking at the faults that is happening. Then through that there's a method called policy learning or value learning. So changing that policy learning part. That is how they are.
So I want to know how to prepare for the project related to AI and that's the topic I will research.
Yeah, the research. So basically, what we do I will tell you what is happening at SL Applied in our faculty, especially in our department. We have a third year project called the design project. Right? Design project. So in the design project, what we tell you is, so there's Dr. Irangar and myself. We are handling when we are handling our research groups, we make sure that these people are doing learning the small stuff like the fundamentals of AI in third year. So they do a project, we don't restrict them. If they say that okay, they have to use YOLO, we are not saying anything. Okay, you use YOLO. Why? But you have to reason why. You should understand how YOLO work is under. What is happening under. Then they figure out that this thing is not normal. Then they figure out because we are continuously, but weekly we are having it. Every week, Friday morning, third year people, fourth year people in the evening. So in the morning they have to come and present. If you are using YOLO, we are not going to use it. But fourth year we are not doing that. They have to come up with their own architecture. Because in third year, this is like trial and error. So it's okay. It's a design project. So then they will figure out that okay, YOLO is consuming lot of memory, lot of this thing, and it's very complicated. You learn this. Then when it comes to the fourth year one, you know what sort of a project should I come. So I would say the suggestion is start doing small projects starting from second year. If you want to figure out what is your fourth year AI project should be, is it a cost effective one? Is it a multi-model thing? If it is an unsupervised learning part, in order to figure out what sort of an AI solution you should give, you have to tackle with the existing. So second year, third year, especially third year ones, we are telling them, okay, you engage with these stuff. Okay, you engage, but not in the like when it comes fourth year, you figure out. They come up with ideas. They say, okay, we saw that in this area, you have to read a lot. One thing you have to read. In order to read, you have to understand what is happening inside this thing. That's why we are letting them to use whatever they want. So you do projects. Do projects only we can figure out. Do a lot of projects. It's very fun. So my advice is do projects, then you figure out what is the fourth year thing you can do now. We also publish. Now third year ones we are published. Not team like Hyderabad or Sri Lanka. I thought to say this, but you have to be honest. I have only because one student didn't listen to me, she went and published in a Sri Lankan journal. That's the only journal that I have published in Sri Lanka. The only journal I have published, I think, more up to like 15 to 16 journals. That's the only one. Others not only give one, but top 5%, top 10%, world's top 5, top 10%. Why am I saying this thing? For students like you. Because when you put it to that process, you learn a lot. You see something that you haven't, because in these redeeming process, they send it to all these top people in the field. Then when you, let's say you haven't seen some sort of a technique, they are proposing. You guys are not looking to this side. Then when you're publishing also you learn. Somehow we tackle the reviewers and we will publish it. But next time when you're coming to 40, you have a good knowledge in that domain. If you're going into agriculture, there are no ensemble model techniques. They are coming with the solution. In third year, we made a cassava mosaic disease detection. It got published into world's top 1% journal. So this is third year. So he made a normal one, but somehow we convinced this thing and we wrote some and we fine-tuned our model. Now today he figured out that in agriculture water is a problem. He is developing a smart AI water pump, which can purify all these sediments, everything. You just pour the water inside this thing, it's getting purified, consumed anytime you want. So this is how you learn. So they were talking about minerals getting into this cassava, this thing, and he figured out that there's a problem in water. AI has not been used in water, and he has gone and searched. Because when you're writing papers also, you have to read papers, then you figure out that there's an area that has not been tapped. That is also one thing you can figure out what sort of an AI thing that you can. I hope I answered that question. There's another question.
Are there any popular modular compression methods for HAI like you mentioned? Because it always drops the accuracy when we apply.
Okay. I don't know what is the technique they have used. Who put that question? Can you raise your hand? No one. It was a ChatGPT solution, right? Right. I don't know what technique you use, but there's a concept like pruning and quantizing and knowledge dissemination. These are the three methods of compressing an image. Now when you are so when you are compressing a neural network, you can't just arbitrarily compress it. Yeah. Sometimes you might be using TF line conversion. Doesn't compress it like that. So there's a technique called quantization. These are very big theories. You have to underneath the thing what is happening. You have to understand. So let's say there's a technical context. There's a technical pruning. What we do is we merge these techniques here. Quantize and prune and quantize. Then the model accuracy doesn't drop. From the no problem. But when you start this thing, let's say you quantize first and then prune, the whole thing changes. Accuracy drops. So there are techniques. The problem is you guys are still first year, second year people. You don't have the idea of this heavy mathematical part of the machine learning deep learning. But the thing is, search about this pruning, quantizing, and knowledge necessary. So let's say you compress your model and the accuracy drops. What can you do? There's a technique called knowledge dissemination. What is that technique? You can use different data sets. Now let's say, as an example, let's say action facility. Let's say this thing gets blocked. So you can do transfer learning. Right? You can take two data sets, take the common features out and fill in the gaps which has been blocked. Right? That is one thing. So there are a lot of other techniques. But the problem is you have to have a good idea about the mathematical part of it. So that's a problem.
AI or neural networks make sense.
You mean like neural networks creating neural networks? That's the question. Yes, I think so, right? Okay. So which means like it's like a Terminator kind of a problem. Right, okay. So when you put to ChatGPT, automatically they are creating neural networks. You tell ChatGPT, I want a convolutional neural network. It will give you a code that you also don't understand. Even I can't understand sometimes because it's very complicated. But the problem is it can't auto-generate. Cannot. Like Terminator kind of stuff won't happen at all. Because it cannot be sentient. Why? What do you mean by sentient? Like he feels sad about what? Like emotion. Because of emotions only, he becomes sentient. Now, when we were talking about these neural networks, these entire neural networks are logical. Everything is logical numbers. But a human being is not like that. He has an emotional part. What we are creating is the logical part of it. We can't create the emotional part. It's divine, magical. It's how once you see robots mating and creating babies, yes, there's a problem. Until that, there's no problem. So you can't create your own best version all the time, but you have to instruct. It's not a perfect way. So the yes, no kind of thing. Any other questions? That's all. Good big questions. Any other questions? Yeah, no questions. Yeah, you have a question. I know this. Okay.
Right, and that's come forward.
Ah.